So a very good afternoon to one and all present in this online meeting platform. I welcome all of you to this 1 week online short-term training program on artificial intelligence for education and society from 4 to 10 February 2026, organized by Malavia Mission Teacher Training Center, MMTTC, IIT Warangal, Telangana, which is established under the scheme of MMTTP, UGC, Ministry of Education and Government of India. So before we formally start, I request all of you to please rise for our national song.
वन्दे मातरम् वन्दे मातरम् सुजला सुफला मलयज शीतला सस्यश्यामला मातरम् वन्दे मातरम् शुभ्रज्योत्स्ना पुलकितयामिनी पुल्लकुसुमित द्रुमदलशोभिनी सुहासिनी सुमधुरभाषिणी सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम्.
So thank you everyone. Please take your seat. Once again, a very good afternoon to one and all present in this online meeting platform. Honorable Director, Professor Vidyadhar Subdi sir, respected Dean Faculty Welfare, Professor P. Radhakrishna sir, respected Head MMTTC and CTL, Center for Training and Learning, Professor M. Shailaja Kumari Madam, Coordinator of this AI for Education Society, Professor Manjubala Bishi Madam, faculty members, staffs, participants, invited online media persons, and ladies and gentlemen. So it gives me an immense pleasure to welcome all of you to this 1 week online STTP on AI education and society, organized by MMTTC and IIT Warangal under MMTTP UGC, Ministry of Education and Government of India. So this program is conducted in line with the AI Pre-Summit 2026 in New Delhi, which is initiated by NIT Warangal, which is served as a dynamic lead-up to the India AI Impact Summit 2026, which brings together various policymakers, industry leaders, researchers, global stakeholders to shape the agenda for responsible, inclusive, and impactful AI globally. So the pre-summit series included high-level discussions, workshops, collaborative events focused on governance, innovation, ethical AI, talent development, practical application across various sectors, including healthcare, agriculture, education, economic development, amplifying voices from governments and academia and various startups to build actionable insight that feed into main summit, which is going to be conducted in the month of February 19 to 20, 2026 at Bharat Mandapam in New Delhi. So as a India AI Impact 2026, various organizations, including central institutions, are requested to conduct various pre-summit programs. So in line with that program, NIT Warangal has conducted several programs in the past, and we are continuing up to the February 20, 2026. So till now, 1300 plus proposals are submitted to pre-summit events. 480 plus pre-summit events held so far, and there are 7 flagship events, and more than 3 lakh participants are engaged in all these events. Coming to this program primarily focus on AI, specifically in the education and society. So as you know that AI is not just a technological breakthrough, but it is a powerful tool that can transform how society learn, grow, and solve various problems. As we inaugurate this initiative in our institute as a part of this summit, we recognize that AI in education is not about replacing human wisdom, but about amplifying it, making knowledge more accessible, personalized, and inclusive for every learner, regardless of the geography or background. When used responsibly, AI can bridge educational gap, support various teachers, spark creativity, equip citizens with the skills needed for a rapidly changing the world. Our responsibility is to guide this technology with ethics, empathy, and vision, ensuring it serves humanity and strengthen the foundation of informed, stable society. Today marks not just beginning of this particular program, but the starts of a collective commitment to use intelligence, both human and artificial, to educate, empower, uplift our community for generations to come. So this faculty development program having 350 online registrations from various reputed institutes as well as industries, universities, and research organizations. So I thank all the participants for their keen interest in this STTP and choose MMTTC NIT Warangal for learning this particular program. I would also like to thank the expert persons involved in this 6 day faculty develop 6 day STTP from across the country and industry persons to accept our request to deliver the lectures in this program. So this program consists of 24 expert lectures. Each lecture is of 90 minutes. So there is a for this particular program, in order to get the participation certificate, the participant is expected to attend all the sessions and secure minimum 60% mark, which in the test which will be conducted in the last day. So I thank all the participant and resource persons and the faculty members, those who are involved in this program, to make this event successful and as a whole to make India AI Impact Summit 2026 more successful. I warmly welcome all of you again. Thank you very much. Jai Hind. Now I request Professor M. Shailaja Kumari Madam, Head MMTTC and the Center for Training and Learning, to give overview of MMTTC.
Yeah, thank you, Dr. Sanjay Panda. Good afternoon, everyone. On behalf of Center for Training and Learning at NIT Warangal, I extend a warm welcome to our beloved Director, Professor Bidyadhar Subuddhi sir, and Professor Sirish Hari Sonevane, Dean R&D, Professor Radha Krishna, Dean Faculty Welfare from NIT Warangal, and all other invitees and all participants to this inaugural program of the 6-day online STTP on artificial intelligence for education and society. And my congratulations to the program coordinators, Professor Manjubala and Professor Sanjay Kumar Panda, for making this program a vibrant one with 350 registrations. So the Center for Training and Learning at NIT Warangal is dedicated to improving the teaching quality and supporting the growth of faculty in higher education. So the Malaviya Mission Teacher Training Center is an integral part of the Center for Training and Learning. It was originally set up in the year 2016 under Malaviya Mission Teacher Training Program, which is led by the University Grants Commission under Ministry of Education. Our dedicated facility, the Pandit Madan Mohan Malaviya Teaching Learning Center, was inaugurated by the Honorable Minister of Education, Sri Ramesh Pokhriyalji, in October 2020. In October 2021, NIT Warangal merged Center for Continuing Education and Center for Education Technology with Teaching Learning Center and renamed as Center for Training and Learning. So the ministry actually relaunched these MMTTCs in September 2023, with which was again inaugurated by Honorable Minister of Education, Sri Dharmendra Pradhanji. Formerly known as Teaching Learning Center, MMTTC continues to play an important role in empowering educators with innovative pedagogical tools and a forward-looking perspective aligning with the changing needs of our education system. So the MMTTC under UGC sponsorship, Government of India, organizes a range of programs including 8-day National Education Policy Orientation and Sensitization Program, 1-month faculty induction programs, 12-day refresher courses, and 6-day short-term training programs. And these initiatives have benefited more than 10,000 faculty members from various disciplines, including science, engineering, technology, humanities, and social sciences. And our programs align with the 8 core themes of national education policy, such as holistic multidisciplinary education, Indian knowledge systems, academic leadership, ICT in education, higher education and society, research and development, skill development, student diversity and inclusive education, pedagogy and assessment. These themes are designed to foster an inclusive, learner centric, and globally competent academic ecosystem. And additionally, at Center for Training and Learning, we do organize 5-day and 6-day online and offline faculty development programs and conferences in all domains of engineering, science, humanities, and education. So these are self-finance basis. So any faculty member who is attending this STTP who wish to like collaborate with Center for Training and Learning for organizing FDPs and conferences and any other training programs. So you can visit our website under support centers. So coming to this short-term training program. So today artificial intelligence has become a buzzword for everybody. So to my understanding, artificial intelligence is uh, a pedagogical moment for educators also. It is an opportunity for all of us to rethink how to teach, how student can learn, and what truly matters to all of us in education. So AI can provide personalized learning. Also, it can support our assessments, also reduce routine academic workloads. Yet it cannot definitely replace our human elements that define the education. That is the curiosity, compassion, ethical judgment, and wisdom. So, as faculty members, our role is not to compete with AI, but to guide the learners or our students in working meaningfully with it. So, as it is rightly mentioned by the coordinator, so ethics while using AI is one of the important issue that is to be noted. So, AI makes our role more important and not any more lesser. So I hope that this FDP is not just about learning new technologies, but it is about developing a human-centered approach to artificial intelligence aligned with academic integrity, social responsibility, and national priorities. So let us use this program to learn and reimagine education so that AI becomes a tool for empowerment and also for inclusion. So thank you everyone, and I wish all of you a meaningful and enriching sessions for the coming 6 days. So thank you, Dr. Sanjay Panda, for this opportunity.
Yeah, thank you very much, madam, for in the events under MMTTC and programs that are conducted by our institute. So now I request the Dean Faculty of our institute, Professor Radha, to say a few words about.
Thanks, Sanjay. Respected director, sir, head CTL, Dean R&D, participants of this program, and coordinators of this program. Good afternoon to all of you. Let me congratulate the coordinators for coming with a beautiful program in AI with educational society. It's today we can see that AI could be like a buzzword, as I mentioned, as a buzzword. And in industry, there's a lot of things will happen between the automation and AI. Though the computers were actually started with more focus on the automation, now they're making the AI also as part of the automation. So that's why people are calling like a embedded analytics. So that means as the business processes are executing, they want to say that the decisions also can be taken over a period of time. And when 1956 around time, the John McCarthy has actually coined the AI word, but there's a lot of downfall was there in the beginning. But now, once the machine learning, deep learning, data mining, data science, many of the areas actually come up, which can actually taking as like a umbrella of AI. So today, whether we like or don't like, or whether we are knowingly or unknowingly, we are actually using the AI. Even if we have a system, a smartphone in our hand, can be treated as a AI is in a hand. So everything can be done using the systems. So now there are a lot of changes are happening in the education and as well as the society, and we may be already envisaging a lot of benefits from the AI. Today, maybe in the educational system, even the instead of a faculty, maybe a twin, a digital twin of the faculty may come and then teach. So those days may come in the recent in the future. It may come up such kind of advancements. as we can see that in the defense also people are using AI, and similarly any other sectors. So that's the reason even many of the disciplines also started AI and ML focus in their own curriculum aspects. So I believe that this program will have a lot of enrichment for all the participants and give a lot of insights and thoughts over the AI. And also look at the AI is not only from the usage point of view, and also AI may be harmful also. So sometimes we have to be very careful in using the AI. So I actually once again congratulate the participants and the coordinator for attending this program and organizing this program. I wish a great success of this program. Thank you very much.
Thank you very much, sir, for the highlights about this program and activities. Now I request our Honorable Director, Professor Vidyadhar Subudhi sir, to inaugurate this faculty STTP and say few words for participation.
Thank you, Professor Panda, for inviting me. Madam Saileja, the head CTL and the facilitator for this program, and the other coordinator, Madam Manju Valabishi, and the Dean Faculty Welfare, Professor Radhakrishna. So on behalf of you all, I extend a very cordial welcome to all the participants to this wonderful program. So actually, I believe three persons are very important to me today. One is Sanjay Panda and Manjulata Bishi to coordinate this. Two is Madam Saleja who facilitated this. And third is the participant who make it happen. So thank you all for this. And the sponsor is basically all the time Madam is taking the MMTC. That is there are a lot of thanks to them for sponsoring it. And in NIT Warangal, all of you know it is an institute of national importance. So meaning it is a premier public technical institution with lot of national importance and with a strong legacy in engineering education, research and international collaboration. So therefore, we are hoping that this kind of MTP, the short-term course, will definitely will cater the message that we are the people who are honoring the developments of AI in our institutes and beyond our boundaries. And needless to say that our learning happens interdisciplinary manner and with a collective reflection on AI that can be harnessed or leveraged for responsibly for education and societal development. AI today is a global transformative force that is definitely reshape the higher education system in particular, and with a lot of emphasis on research practices, industry, governance, and the society. And today we are all saying that the chat GPT, AI, large language model, they have impacted a lot. And more so now is coming that agentic AI, where not only it will guide you to do something, it will do something for you. So then what do you do then? So then you have to think more carefully how to take the best benefit of this AI. Universities worldwide are exploring AI-enabled learning environments, intelligent tutoring systems, learning analytics, and virtual laboratories. At the same time, AI raises complex questions related to ethics, what Professor Radhakrishna has rightly mentioned, that we have to also honor the ethics part of it, inclusivity, cultural context, and societal impact, which require a shared global perspective. And at NIT Warangal, these AI-related research and applications are actively being pursued across multiple departments. Our Department of Computer Science and Engineering, Electrical Engineering, and Electronics and Communication Engineering are the prime movers for the AI applications, and they are heavily engaged in areas such as machine learning, computer vision, control system, signal processing, robotics, smart grids, cyber physical systems, and many other interesting applications, including healthcare. So this interdisciplinary collaboration is truly happening in NIT Warangal across the departments. But I believe this short course will definitely open new boundaries for collaboration with all the institutes they are representing to participate in this program. And not only we limit to these three departments, we are also involving mechanical, civil, and chemical engineering, even biotechnology, sciences, humanities, mathematics, for almost all application domains and theoretical developments, AI. And one of the areas which is very demanding now in NIT Warangal is AI application in smart manufacturing, infrastructure monitoring, energy systems, and then healthcare technology and sustainable development. So these efforts at NIT Warangal are supported by different research groups, and with advanced computing infrastructure that we have, I believe that they will grow their portfolio for more contribution in this area through externally funded research projects and industry collaborations. And more important for us is that we are looking forward to integrate AI more systematically today for our curriculum design, pedagogy, and assessment in alignment with the NEP 2020. And I am happy to mention here, for the benefit of the participants, that NIT Warangal has consciously decided, its Senate has made a very, very constructive decision to make AI and ML is a course that is available across all disciplines of students, both undergraduate and postgraduate levels. And we emphasize flexibility, interdisciplinarity, digital innovation, and outcome-based education to this AI leverage. And I believe that this short-term course will provide ample opportunity to our participants for sharing for benefiting from the shared global best practices in AI-enabled education, and to explore interdisciplinary and cross-cultural perspectives, and to discuss ethical frameworks and governance models for AI, and to build sustainable academic and research collaborations across different institutes and across also different industries as well. From an Indian perspective, AI also holds immense potential for addressing large-scale societal challenges in education access, healthcare delivery, agriculture, urban infrastructure, and public services. At the same time, it is essential that AI solutions remain human-centric, transparent, and equitable, especially in diverse and resource constraints. Suppose we are talking India, there are only the elite class or the people in the urban areas should not get the benefit. Leveraging AI, we can reach out to the poorest of the poor. We can reach out to the rural areas to solve their issues and to reach out to them. NIT Warangal look forward its responsibility to contribute meaningfully in this endeavor for societal growth. I'm also happy that the government of Telangana is very, very proactive in propagating the AI message even in the schools. And I'm glad that the Telangana government has opened a AI university in Hyderabad, and every works of the governance is now being governed by AI. The first state, I believe, in the country which tries to mandate AI in all aspects of their governance. So therefore, I encourage all the participants to engage deeply with all the sessions, all the resource persons they will be handling, and not only that, to interact with them to take the new directions, new possibilities, so that we can make a big impact in this AI, application in several areas of interest of the nation, and can contribute for the society. So I congratulate the coordinators and Madam Saleja for facilitating them. And I also thank all the participants for choosing this wonderful program at NIT Warangal. And I wish this program a great success. Thank you very much.
Yeah, thank you very much, sir, for highlighting AI activities in our institute. Now I request Professor Manjubala VC Madam to give the proposed vote of thanks.
Good afternoon, all. I feel privileged to get the opportunity to propose a vote of thanks on the inaugural function of this short-term training program on AI for Education and Society. On behalf of Center for Training and Learning, NIT Warangal, and the organizing team of this STTP, Firstly, I would like to thank our Honorable Director, Professor Vidyadhar Subudhi sir, Head CTL, Professor M. Sailaja Kumari Madam, Dean R&D, Professor Siris Sonewala sir, Dean Faculty Welfare, Professor P. Radhakrishna sir, and all the participants present online here for the inaugural function. I would like to thank Center for Training and Learning NIT Warangal for providing all the resources for conducting the program. I would like to thank all the speakers who are going to deliver some sessions in this program. Lastly, I would like to thank all the participants who have registered for this program. Thank you, one and all.
Thank you very much, madam. Now I request all of you to rise for national anthem.
गणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. Please take your seat. So we come to the end of this inaugural session. So we'll start the first session by Professor P. Radhakrishna sir, who is our Dean Faculty Welfare in our institute. So before sir will start the session, let me introduce Professor P. Radhakrishna sir. So Professor Radhakrishna sir has been in the profession of research development and technology adoption for about more than 35 years. He is currently working as a professor at the Department of Computer Science Engineering, NIT Warangal. Professor Krishna is also the CEO and co-founder of NIT Minor Technology, a startup powered by Department of Computer Science Engineering, NIT Warangal, under the Government of India Praya scheme of IIT Bhilai Innovation and Technology Foundation, IBITF Bhilai. His research interests include data mining, big data, machine learning, deep learning, and database and workflow system. Prior to joining NIT Warangal, he served as a principal research scientist at Infosys Lab, Infosys Limited, Hyderabad, where he was associated with research projects leading to futuristic intelligent systems and analytical solutions. Professor Krishna conceptualized numerous research projects in the area of CRM, social network mining, web, sequence, and text image mining, e-check clearing and settlement, and financial inclusion, and associated with building innovation labs for leading industries. He also served as an adjunct faculty at NIT Warangal and IIIT Hyderabad. Professor Krishna also served as a faculty at the Institute for Development and Research in Banking Technology, IDRBT, which is a research arm of Reserve Bank of India, and an associate institute of University of Hyderabad, and as a scientist at the National Informatics Center, Government of India, Bhopal. At IDRBT, he was advisor to many public and private sector banks in India for the implementation of end-to-end enterprise-wide data warehouse and business intelligence solutions. Professor Krishna was also a member of the IT Advisory Committee, Insurance Regulatory and Development Authority, IRDA, India. He has been a member of Research Advisory Committee of several academic institutions. Also, he has been a member of editorial board of various reputed journals and reviewer of many reputed conferences also, including IEEE Transaction on Knowledge and Data Engineering, IEEE Transaction on Service Computing, Information Sciences, Data and Knowledge Engineering, Information System Frontiers, and Software Computing. Professor Krishna has double PhD. The first one is from Osmania University and second one from IIIT Hyderabad, and 20 US PTO granted patents, authored and co-authored more than 6 books. He is also tutorial speakers at several international conferences like ER, ICWS, WWW, IEEE Services, CAISE, ICSE, ER, and DAS FAA. So with this short bio, I request Professor P. Radhakrishnan sir to start the first session.
Thanks, Sanjay, for the again long introduction. So
Sir.
let me share my screen. Can anyone please confirm that my screen is visible and I'm audible?
Yes, sir. Please go ahead.
Okay.
Sir.
Yeah. Good afternoon to all of you.
Good afternoon, sir.
As a first session in this program, so I'll try to make you the maybe more encouraging things to say towards the AI, but we'll see that how best that we can able to cope with the many of the points that can be good enough to know about AI and its applications. I mainly try to focusing the kind of evolution which has happened over a period of time from the starting from the AI to the generative AI today. And you can see that there's a lot of trends are happening. And if you look at the kind of the human evolution which was happened over a period of time, but today we are talking about our neural networks. So where the neural networks are keeping eye on each and every aspect of our life. You just see that when maybe the future is completely with respect to the neural networks, or maybe outcome of the neural networks. You can see the trends which are happening in the AI. I'm just mentioning like we know that C and C++ kind of things. I thought maybe it could be like AI and AI++, because it is very difficult to draw a boundary which is AI and which is not AI today. Because many of the things will happen in the back end, right? So drawing a boundary will be a very difficult, and sometimes we may have a thin boundary between the different technologies. Like the technology could be like a machine learning, could be a deep learning, a NLP, or maybe robotics, or maybe computer vision, or any kind of things. So there's a lot of technological advancements that happen, and at the same time, what we need to be understand is the data also be evolving, because the olden days we are actually talking about more scientific data, or maybe something like a numerical data, or maybe something like a relational form. Now we are talking about more on the unstructured data, which could be generated from the can be documents, could be video, or could be audio, or even the machines also can generate data today. Because if you look at the IoT sensors or IoT devices, or maybe the cloud devices, or maybe any other device, machines like robots and everything, they also start generating the data. Now we need to see that in our whole spectrum of this AI, and the kind of a benefits that we get from the AI, and at the same time that how best that we can use this AI technologies, and maybe the learning aspects of the AI. So then let me start with some of the cartoons, of course for the fun side, but very good, give a lot of good details about it. This was the cartoon which was taken from the kdnuggets.com, which was provide lot of information about the AI and then big data analytics and kind of aspects. It's a very good site to get even the events, providing having the data sets and all the things. Some of you may be interested in knowing more about these things. You can just log into kdnuggets.com or even the datascience.com. So these actually provide the new updates with respect to the events, with respect to the conferences, with respect to the data sets and everything. So in this one, actually, there's a old couple who went for a dinner, and they want to actually order food, and they call the waiter, and then the waiter comes, and then he says, "You just smile. Our AI will take a picture of your face, and will know exactly what you would like for dinner tonight." So that means this AI app that is available in the smartphone can able to detect based on your facial expressions, or maybe the kind of a lip movements, or maybe the eye gaze kind of information. So it try to understand how much hungry you are, and what are your interest, and what is your taste, and maybe what is the kind of a menu that need to be maybe you are going to be likely to order. And it also may be knowing the information about the past, what you are taking in the breakfast, maybe in the lunch, and all the aspects were known, and it will prepare a menu for you. So that means the menu is actually automatically can be generated. That's what the waiter says. That's very nice one. But in case the AI was not able to predict it properly, maybe we may get some kind of a food. It is very difficult even to see or to visualize it, right? So that's why we have to be very careful in when you are using the AI. That's what that the AI is being used to make a decisions about your life, whether you like it or not. Now take another interesting cartoon where the old couple wants to go to the dinner again, the same kind of a dinner. They have to go for a dinner, but the reason is they're saying that the refrigerator is not speaking to the stove. Now you can see with respect to the advancements in the IoT, all the devices also more intelligent enough so that they can communicate each other and get the things to be done. Now here the one is the refrigerator, another is the stove. In case the stove cannot connect to talk to the refrigerator, maybe it may not be knowing that the kind of vegetables that you have in the refrigerator, or the kind of the amount of milk that you have in the refrigerator, it may not be able to know it because of the not having the connectivity between the devices and not able to share the communication between them. So obviously they cannot perform the task that was assigned to them, right? So obviously here in this case also maybe people has to go for the kind of looking for going for a dinner. Then let's look at the autonomous vehicles. Mostly the self-driverless cars. Once started the Google started like a self-driving cars. Right? So similarly, the autonomous vehicles were there. This is like a edge AI because there are several facets of AI were available today. Many of the things which as we go progress, we can come out with many of the AIs. This is the edge AI, making the edge device to be more intelligent enough. Because normally if you look at the 4-5 decades back, most of the things are happening like a historical data, and learn the things from the historical data, and maybe do some kind of analysis after the data was produced. But today in the edge AI kind of environment is looks at as and when the data arrives to the us, or maybe to the system, it should be able to understand that what it can able to resolve. So now here in this case, you can see a particular vehicle, each and every vehicle has to get the signals from the other vehicles. That means it has to need to the process data at real time. That's more important. It cannot be say that I can do let me store my data and then do the lot of analysis and finally take a decision. By the time you may reach to your home also, right? So this here you can see the data has to be taken from not only from the same car but from the other vehicles also, and it has to know the road conditions, like it should be know the lanes which are drawn here. The lanes has to be identified. Maybe other kind of vehicles, maybe the road signals, like sometimes we'll have a zebra signals, maybe sometimes you'll have a stoplight, or sometimes the pedestrians will be there, or maybe the crossing and everything. So that means the variety of the data has to be captured and has to be processed at a real time. That is more important. So now, how much of the processing has to be done for that one? Today, if you look at the high-end cars, they already have a collision resolution system. That means even if this car wants to go faster than this one, and if there is chance of colliding, it automatically slows down. Even increasing the speed, it will slows down. And whenever you're making some kind of a turning, it also decides that how much torque you need to apply, right? So that means these systems are the cars itself will become like a more intelligent enough, saying that they can able to take you without any human efforts. And today it is in reality, in the real life also, there are several places. Even if you want to park the vehicle, you just say that get down where you want it, and the car automatically will go and park the place. So such kind of things are happening. But of course, from the computer science perspective or maybe AI perspective, the important is it has to choose the right algorithms. It is to choose the right algorithms to process the data and get the decisions in real time. Then there are another interesting thing is the connected components. Today, almost all the devices are connected. And we know that maybe it could be like a smart welding machine, a smart welding machine, or maybe a smart TV, or maybe a smartphone, maybe it could be a drone, or it could be a solar panel, maybe a robot, or it could be a human being, human in the loop. That is also be a interesting study in the AI. One is that one, like a human in the loop. Okay. So now you can see here, when each and every device is actually a different one, and different means it actually produces a different kind of a data. And when it is connected, the data has to be looked at, with the different types of the data has to be looked at it. So one of the research area which is starting is called like a information fusion or data fusion. So this is like another area. So how to fuse the data which is coming from the different devices, obviously there are different data types, and fuse them and could be able to analyze the data and work for some kind of a task. So this is data fusion is it's not simply concatenating the most of the vector formats, because today every data is converted into vector format, and people are using simple concatenation. That may not be enough. So if you look at, there's good number of journals also there on this information fusion. So they want to focus more on how best that we can able to consolidate or maybe compile the data coming from variety of the devices and go. So that means, though you can have your data can be stored in the cloud, or it could be stored in the edge, or it could be stored in some different data centers. Maybe the data is coming from the different kind of a variety of the devices. So one has to be done. One has to do the task. So that's what even the big data, when we come out to the big data, we usually talk about volume, velocity and variety, viscosity, virality. There's so many things for there, like a value, many things. So we need to support today about the AI actually today support about all these aspects. So that's why the connecting components, whenever the connected components, obviously we should see that on how best that we can take advantage of the data that is generated from each and every device and take appropriate function or maybe task to be done. This is another interesting aspect what AI actually bring today is like a robotic dog. Maybe some of you may be seen once the Operation Sindoor was done, the people are started. Our defense ministry is actually looking for these robotic dogs. They're looking at the border of our country border. So now here, this is in this slide you can see the robotic dog actually patrolling the Trump's convoy. So now, how much has to be carried out by this robotic dog? So it has to understand what could be a car, and maybe there may be multiple cars are in which car he may be there, right? And that means you should do some kind of object detection. The car means is an object detection from computer science point of view, from image processing point of view. It has to identify the other vehicles, and it has to identify the plants. It could identify the lights. It could be identify many things. So now, just imagine the AI which is supporting it. You can take this information you can get from some kind of a video signals and everything, but because this is a kind of a robot, and it can able to capture the data from the other side, the longer distance also. So that means as a human security is maybe patrolling could be a different from this robotic dog, because it can able to capture the signals that are coming from the longer distances. So you can able to coordinate and combine with them and see that how the patrolling can be done. So that means it has to take the information from the multiple places, multiple locations, and also it has to be see that one the narrow down the kind of a activity that has to be done. So that is more important, because we cannot say that going on, because if you say video feeds, continuous video feeds comes, and it is like a huge amount of the data, or sometimes it could be go into the petabytes of the scale also, right? So this is another again an interesting one released by the Gemini. Many of us know that one Gemini is also a kind of a LLM. It's called a multimodal LLM. This was released by the Gemini itself when they initially launched this LLM. They given this an input image which is like a face, and it given a kind of a prompt saying that one convert this image into a watercolor painting Scott Klee style. So now for this is the prompt and this is the image. These are two of the inputs, and the Gemini actually given the output like this, and you can see the painting. Of course, maybe some of you may be good in painting. I'm not. I'm not exactly knowing what is a Scott Klee style, but I can understand that there is a from the transformation which is coming and the output generated by the this Gemini. You can see this is a face. This is a face, and this is like an output image, like a painting. Are there any correlations between these two to generate such kind of a image? Right? Maybe if you look at it from the object perspective, may not be, because one is completely a faced one, and another is completely like some painting, which is not having any human involvement there, right? So, but you look at it carefully, look at there's kind of a color combinations, right? There may be some kind of a color combinations, or maybe the texture which was there in here. So many of these things may be taken from here, and then maybe taking some other things from the other prompts and trying to generating this one. So that means today you take any kind of a content, either it could be like an image, a text, or any other kind of signals. It is possible to generate a new data which may not exist in the real world. That is the main important. It may not exist it. So yeah, somebody may not be drawn such kind of a things. So that means it is actually able to generate the content, right? So that is actually a new paradigm in today's AI. So this is like of course, not comparing the OpenAI with the DeepSeek, but the kind of opportunities that we have today, like OpenAI, and also when China was started, they released the DeepSeek. So there's tremendous change was happened, right? Either in terms of the processing, or in terms of the analyzing the data, or in terms of developing the applications on their own. So now we have of course, we have a set of LLMs today, like starting with the ChatGPT, BERT, OpenAI, and the DeepSeek. There are many other things for there, right? But the point is, if at all, if we have a multiple LLMs in place, and can we believe one better than the other, right? So, and earlier, if you have a lot of machine learning algorithms, if you look at it, like we have maybe KNN, having SVM, can be decision tree, can be K-means. There's so many algorithms out there, and we may be knowing that which algorithms may be good at what different tasks, like a classification, clustering, and again, right? Today we have a lot of LLMs. Now again, it may be a similar situation may arise for us, saying that which LLM is better for my task. So that means a new avenues for the new innovations may come up. We're saying that one which LLM can be taken into consideration, and maybe which LLM can be further fine tuned with our own data. So then look at the generative AI. That's what today's the trending topic. So it's nothing but it's like a set of AI methodologies that can produce novel content that resemble the training data that were exposed to. So now this is the more important. The words if you look at it, that means whatever that it is exposed in the past, that is coming from the learning. Right? There's the knowledge coming from learning, and that is actually helping us to produce the novel content. That's why all these models actually trained based on a huge amount of the data. If you look at the ChatGPT itself is saying that they actually trained like a 540 billion parameters. So in case if you want to train 540 billion parameters, that means how much data has to be, it's supposed to be trained. Maybe a lot of Wikipedias, and maybe several blogs, several documents, and historical aspects, many of the things, right? And if you look at the multimodal, then it will be much more larger than that. So that means basically this generative AI talks about generating the new content, or maybe you can say it could be like a synthesizing the text. Even today, you can generate the code, and many of the programmers were writing codes for days together to solve or to develop a particular solution. But today, the AI itself will try to give you code. The generative AI, that means the LLMs will try to give the code. Even many of the people do their software engineering projects, and the software engineering life cycle itself is a very longer process, and the design artifacts are very carefully looked at it. But today, there are several LLMs are there which will try to focus and give you the system design itself. So that's why some of the project engineers in the industry, they used to tell that earlier we used to take like 3 to 4 months for just for designing the proper system. But today we are doing only within hours. Only thing is required in the rider is after generating the design, somebody has to be careful to create whether it is practical or not. That means whether the system is generated, whether the generated, of course, because it's trained on a data, based on that it is giving information, and sometimes it will go for hallucination or everything. So we need to be, as a human, has to be let us careful whether it is workable or not workable. But you can see the man hours and man months which are reduced it by having an AI. So that means this AI can be considered as a taught to be used. That means there's like almost like what a human can able to explain or maybe explore kind of a things. Of course, there may be sometimes there is it can also do mistakes. That's what we have to be very careful in understanding or even we have to be ready for that one. Not only understanding, so we have to be ready for that in case if the AI fails properly doing it. That is maybe because of the hallucination and everything, it may not give sometimes a correct representation. So many of the things you can see, some of them are actually doing the presentations also I've seen. Even if you ask the ChatGPT to say that, okay, can you give the references, and those references, it try to give the references because it may be trained on a huge amount of the data. Based on the keywords that you provide, the prompt that you're mentioning it, based on that, it may be provided one, but it may not be exist at all. So that is actually one has to be very careful. So how it can be done? The idea is actually the synthesizing. Some of you may be good at knowing that synthesizing the signals, right? In signal processing and everything, you may be look at network analysis and synthesis. We used to do that. But here, if you look at a particular, maybe here in this case, you can see the simple like a apple, the green apple is there. Suppose if this object to be detected by a system, now what happens is we try to give this object like the similar objects to this one. We'll give multiple objects and try to maybe try to the model to be learned. But suppose you look at somebody has actually given a training on the different faces, and suppose you kept your side face, will they actually recognize the face or not, right? Maybe you can try with your smartphones when some of the people are taking there. If you take it, you will get some kind of a hyper box. You can get a box. It indicates that it is recognized the faces, right? Not recognize it, detect the faces. And sometimes you can see some people who are actually standing side by, it may not be able to capture, right? That means the algorithm is not that much of the capable of taking the faces in case if you are only giving the partial information. So for that, what will be done is, if at all if you want such things also, then better to be synthesize it. So that means try to look at the same object, you make into all the possible combinations of it. You split it. Maybe you can slice into it like this, or maybe slice like this, slice like this. So you try to get many of these portions, and that means many of the variety of the shapes of the same apple you take and then train it out. That's what the synthesis is coming. Even you can see in the ChatGPT kind of things, you have a words, and these words in the trained data, all these words we call like a tokens. So these tokens actually given to the system, and you will try to learn not only this word with existing with these words, but based on the training data, the same word may be there with a different context. That is the reason why people are saying your prompts has to be more careful, more appropriate, if at all if you want to get a desired result. So that's why the new disciplines like a prompt designing and prompt engineering has actually started to say that how effectively you can write a prompt so that you can get the answer which you are expected or which you are looking for. Otherwise, what will happen if at all if these prompts are not proper, then you may not get a proper result. So that's why it is possible, because of the models are actually trained and the data which was further synthesized, right? So that's what you can see. You can see this ChatGPT kind of things can add, it could be audio, could be code, could be image, text, simulations. And today we can say anything, whatever that we want, just go to ChatGPT and then write it. But of course, some people may look at the different way, but it's always good to take the advantage of the automation or maybe the tools that are available with us. Because earlier you can see, suppose somebody wants to do a PA research and they were to go to for a large number of papers and consolidate those papers and finally look at what is exactly was done and what are still gaps are there and what needs to be done. But of course, today if you have a documents, the papers that you have, and suppose instead of a human being, a ChatGPT is helping you out to do that one. Go for all the possible papers and everything and consolidate that one. That is possible, so that you can better concentrate on your knowledge part. Right? You already know what existing works. Of course, you have to supply the data. So then, based on that, you can try to focus more on the novelty part and the execution of the maybe experiments part and everything. But if you look at the same this literature survey, it may be like a 20-30 years back, we used to write a postcard. We used to write a postcard to the others saying that, can you please share your data? Can you please share your paper? So they have to send again by post. And it itself takes like almost like a 3 or 4 months time to get this cycle, to get a paper in your hand. So when the web search engines are actually minimize that kind of effort, now of course the ChatGPT kind of two LLMs can help us to further minimize the efforts in the whole literature survey. So how this generative AI is actually looking for works for is means you take any kind of a data, could be like a text or image or any other kind of data. So we use actually doing a pre-trained model. That's what called like a pre-built model. What it does is like take all kind of a distribution of the tokens, because as I mentioned, if you have all these kind of words, it takes the distribution, variety of the distributions we try to consider, and finally make to say that one you can able to build or maybe generate a new text or new image. So that's what these draws like a traditional AI, which is there earlier based on the statistical pattern matching, machine learning, deep learning kind of things. Their importance is mostly to build a model which can be useful. Either it could be like a deployed online or maybe offline. But the idea is you take the data, maybe split into training data and test data, and then build the model using the training data and test check that system using the test data. Right? So that means the outcome of the things is like a kind of a model which can be good enough for predicting the future, mostly for the given new data points. But today, in the generative AI, this model is actually enabling us to develop develop the content. So now here we can see that the input is a data and output is a data. Right? So for the data which you are given as for training purpose, and now you are expecting some kind of a content again. Earlier, we are only stopped at the prediction, because just I want to know what could be the sales for the next quarter, the sales, how much of the sales that can be done, or maybe revenue can be generated in the next quarter. That is only the idea. But now we are asking that you generate the product itself. I want a new product. I want to give the new product to me. Okay. So that is, we are actually talking about the content development, generating the new content. That's what the generative AI actually talks about. So
Hi sir.
yeah, please.
The diploma visited the meeting.
Any questions, please? Okay. Maybe some other discussion, I think. Any questions, please?
No,
Okay. So that gives us actually looking at two extreme directions. One side is the automation, which was actually started a long time back. Because today we have a large amount of the human tasks are actually automated. and the other side is the AI, that is the artificial intelligence. So that means we want to take even the look at like a human being. So now just look at the systems, the development. When we say something, somebody says that I can write a good programming, that is possible when we have a clear specification. Suppose somebody asked to given a numbers, can you sort it in ascending or descending order? So we have an algorithm, that stepwise process was there. How I can able to do the task, and then I can write a program for that. So in this case, we need a clear specification for both the what is the input that we are giving and what the output that we are expecting from the tool.
అప్పుడు ఈ అడ్మిషన్ పెట్టాను సార్ మర్చిపోయి అది మేము పెట్టుకోలేదు సార్ మామూలుగా ల్యాప్టాప్ పోకుండా అడిగినా సార్ మాకు అలా కూర్చున్నాక దయ్యం ఉండడం అని ఇంత అన్ని సార్ ఇంతమంది వేరే సార్ ఎక్కడ చేయడం మర్చిపోయాను సార్ అంటే ఫస్ట్ పోరా ఇంటికి కదా సార్ తెచ్చుకో సార్ మర్చిపోయాను సార్ ఫస్ట్ పోరా ఇంటికి పోరా ఇంటికి పోవాలి సార్ చూసారు సార్ చూసారు సార్ ఇంటికి పోవాలంటే మళ్ళీ ఇంటికి మళ్ళీ అంటే మధ్యాహ్నం క్లాస్ పోయినా సార్ క్లాస్ రాసుకున్నాను పోయినా మళ్ళీ చిత్తారామ ఊరికి అందరూ ఎందుకు రా అంటే
Okay, now we are good. So now in the learning aspects, we take a huge amount of the data. Maybe here is like object detection, and many famous example of in the deep learning who are teaching, they say that there's like a cat, dog kind of a things they teach, and they build a model. The model is nothing but having the kind of a here it could be like a CNN, right? So finally, try to provide what is this object, right? But in this case, the idea is you can look at the, suppose if I want to take the kind of a characteristics of a cat or dog, most of the things may cover same, right? We do not know exactly how to differentiate from the system perspective. So that means we may be not able to having a complete information, or maybe the imprecise information may be there. So whenever we have such kind of a things, then you build a model, right? Can you build a model or maybe a function which satisfies that intent? That means which is actually unclear. That's more important. So now basically what happens is, if you have this kind of a objects and then you want to detect it, the system is supposed to be having the position to distinguish, right, from one object to the another object. So that's what the learning talks about. So any learning aspects will be, the purpose of main learning is to distinguish each and every object. That is more important. So that's why we are actually looking for developing these models more and more complex, in case if we are not able to do the things. Suppose assume that one you actually if you are standing on a road, and then if you want to look at the devices, the vehicles which are going on the one, maybe when I'm standing here, I might not be able to distinguish all the cars because some bus may be there which may be hiding the several other vehicles. But the same thing, if I go, if suppose there's a building will be there, I go on top of the building and see from there, then I can see all the vehicles, right? So what I'm trying to do is, maybe in the earlier, I mean the two-dimensional, the X and Y, where I could not able to distinguish each and every object. Now I'm going to the third dimension and see that one whether I can able to distinguish the objects or not. If I do, it's okay. If not, then I will go for other dimension, number of like a fourth dimension, fifth dimension. I can go to nth dimension also. Right? So that indicates that we are all the models, like this is like in a support vector missions, we usually go for a hyper dimensions, right? Because we want going to till we reach to the point where we can able to distinguish in the objects. So that's what the learning actually helping us. Now we look at how the evolution has happened. So starting with the AI, where most focusing on the searching techniques. That's the initial AI. If you look at the textbooks on the AI, they'll more focus on the search techniques like A star, AO star kind of things. And there's like half of the portion of the book you can see on the logics. So one of the basic aspect is the logic forms, defining the logic forms. So maybe they can use like a predicate logic, proportional logic, Horn logic, descriptive logic. Many of the logical forms are available. So logical theory are available. One can use it, but the idea is to write the rules, to represent the rules. So the initial AI, the traditional AI, is completely based on the rule-based systems. The rules are actually given by the domain expert, somebody who is having experience in that field. They try to provide the rules, and those rules a computer scientist can code it in a package. So that's why you look at the first expert system, which is Mycin. Mycin is the first expert system, which is actually having thousands of the rules for finding that, for given a symptoms, to find what could be the disease that they are having. This is Mycin. This is the first expert system, right? Of course, today we have a much more advanced systems. So this is a thing is that the rule-based systems. So what is the background of this AI when they started? Because when they started saying that one can machines have the capability of thinking. Machines have the power of thinking. That means, can they actually mimic the human beings? Right? That is what the idea that where the AI was started. The machines are there. Can the machines can think as like a humans? So, but now we do not know whether machines. Then we can say at least today with the IoT advancements in the IoT, the things also started thinking. Maybe the cartoons which you have seen earlier, like a refrigerator and LED and everything, that even the things also started thinking, right? So that means we can really say that yes, this is real, that machines can have the capability of thinking. So the idea is the mostly that is happening started with the AI, started with the rule-based systems, and the only thing is the rules can be coded in one or other form. And today, if you look at the old generations which they started this AI, they code in like a Prolog, Smalltalk, and all the things, and they are much more powerful. Even you look at the Apple actually brought the Siri, right? So it is also written in the Prolog. So then there's a machine learning. This is again a much more popular term, machine learning and pattern recognition. So here, the machine learning, you try to look at there's a kind of a data set. You have a huge data, and you are applying some kind of a learning paradigms or learning algorithms like a supervised learning, unsupervised learning, reinforcement learning, deep learning, any kind of learning, and finally you will get the patterns. Or you can call the patterns can be, you can call it patterns or insights or knowledge, or even you can call it as rules. Rules also be patterns only, right? These are things will be there. Now, what is happening here? You have a data, and using some algorithm, you are trying to get in the rules. In the earlier, what we did is we are having an expert in that area. He is giving the rules, he is specifying the rules, and then the rules are we are coding. Now, these rules are automatically discovered from the data. That means the knowledge that is actually gained over a period of time is embedded in the data itself. If it's not embedded, you cannot discover it, right? Then there's no use of these rules. So when we are using these rules, that means that the data that we are using or maybe generated from the multiple transactions. We can usually call it a transaction data, right? That is helping us in actually discovering the rules. That means it is having a knowledge about the enterprise. Like suppose if you are actually doing a kind of a banking transaction, if the banking somebody has done on behalf of you, maybe somebody else falsely done the transaction, is it possible to you to say that one it will be likely to be fraud in the future, or will it likely to be fraud if it happened? Maybe if suppose some patient comes can you say that when it's likely to be maybe affect the cancer? That means unless you don't have the data, that is the knowledge is not embedded in this one, whatever the algorithms we use, we may not get this output, right? So that's why we are saying the transactions are more important. And many times people say that when the organizations which are having a more and more data, they are richer organizations. Why? Because they can understand their customers. Now, suppose if I know that maybe you are doing some kind of a transaction for your bank, such as you are using the ATM transaction and you use a credit card, and then after that you maybe did some kind of a payments, and then maybe after that you maybe purchase at a superstore. So by looking at all these things, I can able to understand your spending patterns, right? From these transactions, I don't require to ask you how you spend and what is your spending pattern kind of things, but I can get, if I have this kind of transactional data, I can able to get what kind of spending patterns of you, right? So that means the rules are discovered from the data. The data is making a more and more importance, saying that okay, from this data you can able to discover these rules. Then there's a tremendous shift has happened, though the machine learning was started in the earlier, but data mining becoming popular than the machine learning because it's direct solving the problems, solving the business problems. That's more important, because it could be like when you apply a loan, once you say that manager can say that whether it can be sanctioned loan or not can be sanctioned, right? Maybe suppose if you have an insurance policy and you want to do a claim, whether you are eligible for a claim or not, or maybe how much amount that you can claim or not. So that means the data mining actually helping the business problem, solving the business problems. Now we have a variety of algorithms, as we have seen earlier. There are a variety of algorithms are available, but all these algorithms, like you just assume that in a decision tree, the decision tree you can use for the banking purpose, banking claim, fraudulent claim, or maybe insurance fraudulent claim. It can also be done, possible, right? But when you want to use for a particular domain, you require domain knowledge, a domain vocabulary required. So what data mining actually does is, in addition to the machine learning algorithms, like what are the algorithms you have, of course, you look at the data mining, also have another set of technical like association rule mining. That is in addition to the machine learning, what you have a classification, clustering, and regression techniques. Otherwise, both the classification, clustering, regression is almost the same as in the data mining and machine learning. So, but after applying, in addition to you are applying the algorithm, you require some kind of a domain vocabulary also that actually clears us that how to solve the problem in that particular domain. Then there's agents and robotics, where today, as you have seen earlier, also I had mentioned that an agentic AI, that is a buzzword again today, the agentic AI. So these agents, maybe when you open any kind of website, you may get some kind of a window saying that, okay, may I help you, right? That is a chatbot. So that means these are like a chatbots, could be like or you can say like a soft bots. Maybe the robots could be like a hard bots, right? They may be hard bots. So the agents, what is the actually advantage having these agents? Normally, if you in the real life, when we approach for a driving license, we may approach the agent, right? Thinking that the agent may be can do quickly our job. We also can do it, but instead of doing our own, if I ask some agent, he may do maybe quickly or maybe more effectively. So the idea is he may be having a separate knowledge, additional knowledge he is having about that particular task. That's why he can able to do that. Same thing here, the agents are actually having a specialized skills they are having. That means each and every agent actually trained for a specified thing. They can look at the environment and can take a decision. So that means they can take the actions based on the triggers, which are the events that are raised. So and also whenever you want to have a multiple tasks to be done for a particular solution or particular information, so then multiple agents can be collaborated. That's why we call it multi-agent systems or collaborative agent systems. Right? So normally what will happen, if you say that if you are asking a query, you can get a response. Right? So that means user is asking and system is responding. Maybe if you require some information, then you have to go to and see the database and come back and look at it. Right? But suppose that means the agent, each and every agent has to be having a special skills. That means they're specially trained for that activity. And like that, you can have multiple agents. And today, everything is developed in the form of agent only. That's why the agentic AI is coming up. So that means everything like the agent, it can look at it can work on itself, because by looking at the environment and then take appropriate actions. This actually related to gone to the autonomous systems. That's where we've seen the edge AI, autonomous vehicles, and everything. The autonomous systems is having a capability like a self-learning or self-configurable. There could be a self-learning or self-configurable systems. So that means they can have a capability of looking at the situation, understand the situation, because the understanding is more important, and then do the task, right? That means you may be trained the agent, but that may not be enough when actually in the real world or real applications. Then it has to do on its own and then take a decision. So there are many of the projects that we have where you require the kind of autonomous agents. And now there's nowadays you may be hearing about the lot of pipelines, right? The oil pipelines, because the oil which are coming from the Russia or America, there are a lot of things are happening, right? So now you can see when between the countries, when oil is coming, oil comes from to the pipes, right? And these pipes are actually laid down in the sea. And in case suppose any problem happened in this pipeline, is it possible somebody to find out whether there's a leakage was there, damage was there? It's very hard, right? Now as a human being finding a kind of where exactly the damage happened is very difficult. So then what people used to do is they're trying to send some kind of a material like they call like a pig. So they will send those things along this aisle, and that will take the information from these things and try to look at it where exactly this kind of a damage was there. Normally we call like suppose in the steel industry, you look at the steel industry, the steel plates are actually going with the high heated ovens. It will go through this one because it can be molded in the high heat place, right? It should be heated very high. And then when it comes out, and if you want to see if there's any kind of it was done properly or not, or is there any cambers are there in that one or not. And a human being at this kind of a heart, difficult to visualize it or difficult to see that. So what he has to done is he has to cool down that for some time and then check that and inspect that one. But in case if there's a mechanism, like suppose you have a video of this one, and from the object itself, can you do the camber detection? You can identify the camber detection. So now you can see we are trying to make this one, we are making to the heart, and just for inspection, you are making the cold. And then if you have any kind of a problems are there, then again you have to make it to the heart. Rather than that, in case if you can have it through video processing or object detection, you can do it, the camber detection, then this can be actually carried forward and then do the here. So you are saving a lot of amount of time to do the task, right? So that's why these autonomous systems are bringing a major transformation in many industries. So then the deep learning, these are the buzzwords that you might be hearing many times, but just I'm trying to say that what are the conceptual behind why this is like a evolved things. So here, the deep learning also almost look like a machine learning, right? It's like except the machine they call it deep. So now we need to understand what do you mean by deep, right? So now you look at it here. Suppose whenever you want to have a data and you want to get the patterns or you're applying some kind of algorithms, what is basically required is you need to identify the features. This is more important. So now if I have a data in a tabular form, the relational data, right? So I can identify this each and every attribute can serve as a feature or a dimension. If at all, if I want to have a large number of dimensions to reduce, I can use a PCA and other techniques. But now, suppose if I give you a text a text document I give. If you want to apply machine learning algorithms, how you can apply it? That means we need to extract the features, right? If you give an image, I have to extract the features. If you give an audio, then I need to extract features. Otherwise, my algorithms may not work, right? So the challenge is to identify the features, or the more challenge is identifying the relevant features. So this feature engineering part is mostly like a human involved one. That somebody can say, okay, these are the features that I want to consider for this algorithm. But when you have this kind of unstructured data, then identify the features are very important. So people have started about working on different kind of a feature descriptors, maybe like a bag of words, maybe TF-IDF, or could be like a n-gram kind of techniques. There are multiple techniques out there to identify the features that can be actually given. That feature data can be given to the even algorithm. If it's like image, I may extract the color features, I may extract the texture features, or maybe scaling features, or rotation features. There are many of the features, right? So in all this exercise, what we are doing, in case the extracted features are not good enough to identify detect the, or maybe classify that object properly, that means we need to again look at how the another way of extracting the features. So that means we may not be knowing many of the times we may not be knowing what exactly the features are representing, which features are more relevant. So now, why not we ask the system itself to identify the features? That algorithm itself to write an algorithm in such a way that the system itself will try to say, you try to discover your own best features, right? So I will give you a lot of training data, huge amount of data, and you try to decide it. So now the feature engineering is part of the process. That's what we call like in the deep learning, the feature engineering is implicit, whereas in the machine learning, the feature engineering is the explicit. That means somebody try to do that and then do the machine learning. So that's why even so you look at any algorithms, even initially you have seen that in one of the slide there's a cotton tag. We need to see a lot of layers, usually like CNN layers, right? So except the last layer, all the layers are actually making the purpose of all those layers is to find out the correct features. Right? Correct means in terms of the semantics, in terms of the context, in terms of the knowledge, in terms of the intelligence. So it has to be known that, right? Finally identify the exact features. So that's what the deep learning actually mainly focus on. What could be the features, the feature engineering features can be extracted, so it will do automatically. And whenever you want to extract the features, obviously you need a huge amount of the data. I'm talking like maybe documents like billions of the documents, not in millions. You need to train that one. So that means now we need to see the computational resources also to process that one. Normally, the character processing or maybe pixel processing will take a lot of time. But the same thing, why if you convert into a vectors, vector computations are much faster. Vector computations are much faster. Maybe the numerical computations. So now people have started about converting the data into vector formats. Now we can see one side we are looking at the algorithms, and the other side we are looking at the data also. So the data is converted into vectors. So we have word to vector, we have like a sentence to vector, paragraph to vector, or maybe say document to vector, image to vector, audio to vector. So now everything is in vector format. So whatever the algorithm that you're using, any tools you use, first the data is converted into a vector, and then you're doing operations on top of the vector. So that means the representations also be more important. One is the feature representations, and the features which you identify, that features has to be represented in a proper format, so that it can be trained faster. That's what we call it like a representation learning. So this representation learning and the feature extractions are the core aspects of this deep learning things. Then there's a slightly deviated one, but more focus on all the things we call it data science. So the data science indicates that you have a task to be handled, and you can use any of these algorithms, whatever that the algorithms you can apply on that, or even simply you can use Excel sheets You can use Excel or maybe simple tools that you can use, and try to get that whatever that you get a rules or patterns or such everything. But what data science says is, whatever you are generating, identifying the patterns, that will be useful to the businesses. That means it's supposed to provide some kind of a added value to your business. You cannot say that I got some good ideas. That's not enough. That idea should be workable. Right? That is more important. Suppose if I say, if you recruit, I get a rule saying that one recruit 15 people in the next 15 days, you will get a 30% profit in the next quarter. That's very good one, because I'm getting 30% more profit, including even after taking over the expenses with respect to the additional manpower. That is very good one. But is it possible in the next 15 days, can you recruit the skills, the people that require the required skills? One. If that is possible, this rule is good. If that is not possible, even if you give this rule, may not be whole school, right? It will not generate any added value to me. So that's what the data scientist role is. You tell that one maybe how it can be, how it has to be, what has to be done now. That is more important. Earlier, the focus is on how it happened and everything, what happened. Now you have to do what to be done in the future. What you tell the steps, what I need to do. That's what the data science is actually talking about. Then one more area is actually people are maybe listening. Maybe you maybe all heard about the quantum computing. Right? Similarly, in the AI also there's called a quantum inspired computing. So that they want to make this AI to be more advanced, saying that can you work for the quantum computing perspective. Even many of them researchers started about quantum machine learning, the QML, quantum machine learning, and then you can say quantum software engineering. Maybe you can say quantum communications. So maybe many of the things are there. You have to just prefix quantum with the existing discipline. You will get a new discipline, a new area of research. So this is many of the things like with respect to quantum. The idea is that the quantum principles, mostly like entanglement, superpositioning, quantum tunneling, right? So can we use these are the things in our data processing things? So can you represent the data instead of representing the data in the 0 1 form? Can you represent the multiple forms? Why do you limit only 0 and 1? Right? That's what now qubits are said to come into place. So that means you have multiple states of the information, multiple states of the same information. Right? You are having, no, you can, okay. But the output is, you can just look at it in a quantum machine learning. Suppose you take example, you have many models. For a given a new sample, the prediction could be done on any one sample only, on any one algorithm only. But how to choose a particular algorithm? Okay? That could be your innovation. So now suppose simply understand that if you have IoT data or maybe sensor data is a continuous streams. Normally we collect stream data, right? You have continuous streams. Now, if you want to apply any machine learning technique, what you have to do? You may be doing the windowing, right? So maybe like let's take this is one window, and this could be the another window. Like this, you are taking a snapshots, and then you are giving this snapshot as a regular data. But when you're giving the data, and here you check the data, and you have used any particular algorithm and developing this one, that may not be enough, because the kind of a characteristics of this portion may be different from this portion, or it may be different from this portion, right? Now we cannot say that I can give data to a particular algorithm to get the prediction. Now is it possible to have multiple algorithms? I can just make a multiple algorithms, and then now if I develop a mechanism in such a way that the data is intelligent enough, the data itself is intelligent enough to see that one which algorithm is more appropriate for me. Maybe tomorrow you may get such kind of things, right? So that means is this algorithm will passes into like across the algorithms, and this data itself will know that one maybe this algorithm may be good for me. That means we are making the data to be more intelligent enough, so that the changes which are coming up. Right? So that's what in short, the quantum principles, whatever are already available, when you actually make it to the modeling as part of the algorithms to solve some of the problems. Then there's a nature-inspired computing. So look at the nature, understand the behavior of that nature, and model that behavior in an algorithm part. Maybe some of you are having the computer science, so you maybe heard the words like a genetic algorithms, particle swarm optimization, anti-colony optimization, shipyard algorithms. You can see any animal was there in the world, they are keeping on an algorithm. Right? So because each and every algorithm may be having each algorithm animal may be having different behaviors. So similar behavior they want to model with the systems so that they can able to handle some different tasks. Right? Like in genetic algorithms, they say they operate like a crossover, right? You can say mutation. So these are the possible things, right? Like a anti-colony automation, like how hands can be behavior. In the shipyard algorithm, you can see it's mainly used for leadership kind of things. So if one ship is actually going first, and then all others will follow, right? It's like a leadership algorithm. So you have like a butterfly. Almost many of the insects that you have animals, you have algorithms. So the basic idea is understand the nature and understand the behavior, what are the behavior was there, and try to model that behavior as an algorithm, and then solve a problem. So they are actually coming as a nature inspired computing. So then the generative AI is coming into place. Now this is today's trend, right? Generative AI and agentic AI kind of things. So now the even our thought processing also now changing. The AI actually, the idea is, can machines actually having the capability of thinking, right? Now they are not only thinking, they can generate as machines are as humans are generating. So actually content creators are humans, right? Now that also we are leaving to the system. That's what you can see here. The earlier the rules are actually given by the expert. In the machine learning, the rules are actually automatically discovered, but the feature engineering is manual. In the deep learning, the features also are added automatically. In between the agents, they actually train on the specialized tasks. Right? That means we are offloading all our human capabilities. Actually, we are not saying that though we started the machines actually perform like a humans, but now whatever we are actually handing over the capabilities to the machines nowadays. Okay, so that's what now we are asking that the machines also to generate the content. So that means in the whole data-driven world, where you can see that the organizations are generating a large amount of the data, the data sense is more important. That's the means. Data sense means it's like a understanding the data. It doesn't mean that one, okay, what do you just look at this data, can I read it or not? That is not the point. That means you can use any of the techniques, whatever that was there here, any of these techniques can be used, but can you sense the data? That is more important. That means that, as I mentioned earlier, the examples, whenever a transaction is happening, rather than doing a post-mortem, let us do online at that point of time, analyze it. That means look at it and say it maybe leads to a fraudulent transaction. That is more important, because once a fraud is happened, it may be having a huge impact. But in case if you are able to stop one transaction, which is a fraudulent transaction, there may be you are actually saving huge amount of the money. Same thing, if you can able to predict that one, there is a possibility of looking at maybe potentially may come into like a cancer, you can save a life, right? So similarly, there's a many of the aspects can be easily looked into it. So that's what the data sensing is more important. To do that one, we may be required one or more of these technologies. One or more, it may be required. But finally, if you are in that position, that means yes, you can really say that yes, you can able to making the intelligent decisions. So that means where we started is whether machines are having the capability of humans, similar to, they can perform similar to humans. That means the cognitive reasoning or a cognitive sensing is more important, right? So the cognitive sensing, cognitive reasoning is the IP rights. Kind of, we say IP rights of humans. That is, as a human, we have that IP right. Now, what we are saying is we are trying to make the incorporating that kind of a logic, right, or that kind of a knowledge, where we are actually incorporating into the machines. So that's what we want to say, that can the humans, can the machines can mimic the humans. That's what the AI was started, right? The where the you'll say that the cognitive sense can be. We are trying, all these things are actually helping us to incorporate the cognitive sense. And many of the companies, like you look at the Microsoft, they have a cognitive research center. So even all big vendors like Google, Amazon, Facebook, all these people have the separate labs for this cognitive reasoning or cognitive research. So that means whatever that we discussed, to make it in short, we have a traditional rule-based AI. The rules are actually created by the humans. When you say in the classical machine learning, the rules are actually extracted automatically, but the feature engineering is a manual, or maybe the hand designed features. That's what it says. Manual means, doesn't mean that somebody has to tell that reason. We have a automated feature selection, feature extraction methods are there, but that is a separate process itself. So now we are want even the features also to be learned automatically. That's what in the deep learning or representation learning mechanisms we are doing it. Now here another step they are doing it. So now it can be automated learning features and learn decisions. But now assume that one, I develop a model, I had a banking data, somebody asked me to do detect the fraudulent loans, or maybe fraudulent transactions. So now, as a domain, this is kind of a AI scientist, I looked at into this one and developed a good model for this, for doing this one. Now, suppose the manager again asks that, now I have insurance data, can you do the say insurance claims? Can you do this fraud detection in the insurance claims? Now, is it, if you want to start this one again, you have to start from scratch? It's very difficult, right? Is it possible to transfer the knowledge that you gain while doing this one to here? That's knowledge transfer. Right? That means we are looking for a transfer learning kind of things. Sorry. So that means we are going for a transfer learning kind of a techniques. What happens in this transfer learning? Assume that one we have a maybe this documents are there in the loan documents are there in English. That insurance claims also, the documents also in the English, suppose. That means a lot of grammatical things can be taken into account, right? What is not there means here you may be done some kind of additional banking vocabulary. That here you require some additional insurance regulator. So that means, can you develop a model, ready model, and then use that model for these purposes? So this model, this we call like a pre-trained model. This the ChatGPT or maybe the Gemini, all the things are like a pre-trained models. They are actually pre-trained models. And for a specific task you want to do, maybe here a fraudulent claim from the insurance sector, fraudulent claim in the bank sector, you need to fine-tune it. You need to fine-tune for your domain or for your problem. You can fine-tune that model. So this is actually a powerful concept. You say that one, I have a pre-trained, take a pre-trained model and do the fine-tuning. Right? This is all we call it as a transformers. Or we can say these are like LLMs, ChatGPT and everything. They are like a transformers. Maybe because of you have a large data, you may be required a semi-supervised learning or a self-supervised learning is required, because we may not get a labeled data. It is very again another tedious task. What are, if you have a 500 billion documents, and can you actually go for annotate each and every entity? It is very difficult. So that means we should have some kind of a techniques to have like a semi-supervised or maybe a self-supervised techniques. Right? That is important. So that means now these pre-trained models, we can just think about like a abstract features. So that means we are learning the abstract features, not only learning, those can be easily modeled towards to the new problems that we want to handle it. So this entire one is like a complete evolution from the traditional AI to the current generated current generated. The generative AI means like having this transformers, LLM, all the things. Right? Any questions here? Till now? Any questions? I think somebody sent a message. Let me check my chat message. Okay. Not able to see you. Yeah, okay. Somebody wants to. Yeah, Singra,
Hello.
Abhishek. Yeah, please.
Good afternoon, Professor. This side Abhishek.
Yeah, please.
Sir, my question is related to the first part of the presentation where you presented data fusion. And
Okay.
that's where my concern comes, as we generally tend to say that if we are having garbage in, then there would be garbage out. So how we generally prefer to have this data fusion and also keep a check on this, the data that it should not be as a garbage into the algorithms.
Yeah, nice one. Here the two parts. One is the availability of the data, and second is the algorithm, the data that is actually supplied to the algorithm. Right. So now, if it is like a junk, identifying the junk data, that is a different task altogether. That was not in our hand. Right. Suppose somebody comes up. So there is some kind of a techniques people are using it, like a fake data analysis and everything, like a people are saying fake news, correct? Fake news detection kind of things. So similarly, like fake messages, so fake data. So they are coming up. Now the idea here is the once you have the data, assume that when the data is generated by the device are correct in the format. Fusion is the how best that you can fuse it. Suppose if I get a data from the numerical data from a thermometer, that some kind of a temperature information, and some kind of a another information from the maybe another sensor. If it's like both are like a numerical, I can at least take some kind of decisions. But suppose you get sometimes you can take a barcode as a data, and then numeric data at one place, and maybe document at a place, and signal voice can be at some other place. How to be doing it? Particularly in the multimodality when it's coming nowadays, multimodal is coming up. Suppose you take a kind of a world map or maybe a particular location, country location, and suppose you draw with a finger saying that in this region I want to know, maybe that you may be seen recently Google also started that one, right? You want to know what are the good restaurants nearby. So that means you need to take the data which is coming from the finger, that is the gestures also be important, right? The sensing important. So those are things are taking, and then how best that you can do the fuse all this data to perform the task. But what you are asking question is if the data itself is a kind of a junk data, right? Garbage data. So of course that is very difficult to know or even to identify the garbage data. But what you are saying is correct. If you give the garbage data, you'll get the garbage output. We cannot rely on anything of that. They may not be useful.
Thank you, sir. Got my answers, sir. Thank you.
Okay, thank you. Any other questions? Okay, no one is having. Let us move ahead. Anything? Let me check in the chat box. No, there's no. Okay. So now let us see that one. Just I took some of the things from the applications of AI in education. And many of the things you may be knowing it. And particularly with respect to the chat GPT kind of environments, we can develop the content, and that content will be much better than the what we're doing. Even you can do the content creation, not only content creation, you can do the paraphrasing. That is also possible. You can able to condense it, and even you can do the many of the aspects, right? So that's why the people are calling it smart content. So now, suppose each individual may be having a different kind of a interest, and the way of learning also could be different. Right? Everybody may not be the same kind of a mindset, learning capability, and etc. So now, is it possible? Suppose if you have the same textbook, having the same textbook. Suppose if you are reading, if you want to read this textbook, it should looks like a one kind of aspect, and for me it should be different, and for the another person it should be different. Is it possible to give that kind of a perspective? Right. So that means what we can say is, maybe suppose if I may be a fast learner, or maybe I may be knowing that one many of these concepts already know it. By knowing that information, you maybe actually skip some of the content and say provide some of the information, some of the things, so that he will complete it fast. In another person, he may not be interested to read large text, but he may be actually more interested to look at the figures and then grasp from that. Even the equations also like something like a kind of animated things. So then you make this data, take the content, the text content, and make into some kind of a good picture wise painting. That's what you may be seen. Where you look at the child books, children which their study books, most of the things like figures will be there, right? And but our textbooks may not be like that. If you look at an engineering or maybe a higher education, so can you make it, the textbook may be same, the information available will be same, but you are presenting in a different forms. So that may be possible with the AI, right? That may be unable to do that one. Even normally when you are presenting a paper, research paper, you actually write a paper, and you are while you're presenting, you require a PPT, right? Slides. Now there's like a notebook LM is there. Yeah, I don't know how many of you are aware of it. There's a notebook LM is very good. It will actually give the document. It will not only prepare the PPT slides, and if you ask that I want to more figures, it will try to provide you. If you say I want a connectivity between these slides, it will try to give you. So that is the kind of a tools available today. Then this personalized learning. So I think you may have seen earlier also. Today people are actually the education is going towards the completely like a student centric. So that means we need to give an importance to each and every student. So can you actually give the kind of a personal learning environment, looking at each individual interests? That is actually more important. Right? That means looking at each individual, and can you able to support that one. Then there is called adaptive learning. That means suppose if you look at when you are teaching a class, and maybe all the students may not have the same kind of a receptible aspect, right? Some may be fast, can grasp. Sometimes somebody may not be that one, or maybe some other things, right? Is it possible to come out with with the facial expressions of the students? Can you say that whether they learned or not, how much they're able to grasp that subject or not? So these are things are possible. That means you can have like an adaptive to the environment, right? Or maybe sometimes here you can see modify the course of its learning pace. That's what which I mentioned here. So at your own pace that you can able to learn the material. And remember always, sometimes you can say that some faculty will actually maybe go very fast, or maybe some people actually faculty maybe like a teacher, not a faculty, like a teacher. Sometimes maybe shout kind of things, right? Each one is having their own kind of a things are there. So now we are actually, now suppose the system is teaching us, or maybe a robot is teaching us, correct? So that means a machine may not have that kind of a kind of a different moods, right? Even the student are maybe having different moods to learn, but faculty, at least the robot can have the same mood for always, right, for everyone. So that is kind of environment can be used for data accumulation. Then you can see there's a facilitator, virtual facilitator, because the way that you can able to understand can be understand first by the human the software agent, and that agent in turn can able to help you out in arranging the maybe content or maybe pictures or anything, right? Then there's another work which so there's automated grader. Of course, people are asking whether whenever you are when you are evaluating the scripts, can it be possible by the automatically evaluate and grade it, right? So that means is because you may be seen, many of you may be seen in the picture of robo. Yeah, it just read the textbook completely. Right? Yeah. Any question, please? So that is a kind of a automatic grader, and like that you will have many of the things that you can say. Today online exams people are wanting to be proctoring, and today they are available. Suppose the agents are there, AI agents will try continuously monitor the student when writing the exam, and see that one whether based on his eye movement and everything. Of course, students also very clever, and then they can able to take the phone, and then they take the help of their friends and everything. But of course, the proctoring is also be can be AI can help us in doing the lot of proctoring tasks. So now this is also there are a lot of uses for there in the AI itself in the education, like understanding the behavior of individuals, so that you can able to look at the individual one, and then based on the maybe stress that is feeling by the student, it can be adopted, right? So now you can have, and then maybe gamified learning, because we have a good number of tools are available to say that, okay, can you design and then do that one, right? Sometimes you can say, I give a textbook, okay, maybe online content is available, you give the online content, but students reading this one is difficult, and even if he read, he do not know the kind of a complex things that will learn. Suppose if he is preparing an exam, so now he can ask that one, maybe ChatGPT kind of thing, can you give me a quiz questions from here? It will try to make that one. If you ask, can you make some kind of a complex questions from this document, it will try to prepare it. So that means he can get he knows that how much he is able to learn from that activity, right? Rather than only teacher giving a whole content, it is always good to can maybe quizzes, maybe assignments, or maybe programming, or maybe some kind of a workouts. Everything can be done. So that means the system will generate that one, and you are solving. A student is solving that one. Then of course these are a very general repeated tasks like a scheduling and management kind of things, and assessment can be carried out. Then many of the things like people are using the AI heavily in the education systems. Now this is like a digital twin which I mentioned in the earlier. So digital twins in the education. So now if you look at the news, the TV, the news comes, a news reader is reading the news and we are listening it, right? Instead of a news reader, maybe it is possible today to get that we call in our terminology we call like a digital avatar. We call it avatar. That means it is actually a same person appears as a software or a twin. We can say that the avatar that will actually speaks, read the entire news, because a person not required if you are only reading it, right? So maybe, but it always it's not like a one. It's look a real. It looks as a real. That means the movement, everything, and the same. That means they is it like only like a person sitting? May not be. The expressions also should be matched towards the content which is reading, right? Suppose somebody cannot able to laugh when some sad thing was reading, right? Suppose you say somebody maybe there's some sad thing, so you can say laugh, you cannot tell. And the same time, you cannot say something is the very good thing. Suppose you say that I was actually got married. So you say if it's a sad thing, if you tell that to others, it may not be correct, right? So that means the expressions, the mood, and everything has to be the empathy. Everything has to be tuned towards to the sentence that you. So that's the kind of digital avatars. And the same thing in the classrooms also, people can go for this kind of a digital avatar. Maybe suppose you may think that on some of the faculty, maybe they may be teaching well and you want to listen them, right? So nowadays voice synthesis is available and you can have the kind of a twins, that avatar can be there. So you can say that the classroom kind of session can be, you can feel the same kind of environment there. And when we want to have a scaling, today we want to teach content to the like a 400 people and 800 people like that, right? So, and it is very difficult to look at each and every one and see that whether it was actually able to understand or not. So the scaling is a difficult, is actually a challenging task in education. Suppose if you teach a 20 students and you're teaching a 400 students, may not be same, right? But suppose if you get a personalized learning, so that means you had a class, but that class actually, if you actually having the recording and everything, maybe it is maybe possible to give you like a teach specific to the individual, right? In the classroom kind of teaching, that may not be possible, but in the kind of a digital twins, it may be possible. You can have a personalized learning, much more effective learning can be done. Then there is one of the one which currently IIT Bombay, I think they are experimenting things in the classroom, and even we are also thought of having similar thing, where in the classroom we have seen recently, after coming through all the kind of a competitive exams, people are coming to our institutions, and maybe they may be learned in their in their local language, and when it's come here, suppose the faculty may be teaching in one language, maybe the English, and in case if they are not able to understand or maybe take it out from that language, maybe the person, maybe the student will be good person, is maybe more intelligent, but because of the only language barrier, he could not able to understand the concepts. So now, is it possible when a faculty is teaching in one language, maybe the students can understand, can listen the same thing in their own language? So that's what can we say, a real-time multilingual lecture translation using AI. So that's what currently we started one of the project here. So there's one, can we actually do this multilingual, that means can be done translation. And of course, as part of Bharat AI, the teams are there in IIT Madras. They actually translated many of the Indian languages. Of course, they're still not completed, but they're doing many of the languages they translated available. So now we need to properly disseminate that in the classrooms. So then this is which I given that one an example, like if you have a Google Classroom, currently we are uploading the content, but instead of only uploading the content, can you intelligently use that one? Suppose that means it can come out the quizzes from that, or maybe assignments, or maybe additional material, different aspects, right? So it can the same content can be provided into different aspects for the individual student. Then the AI-based detection for student facial expressions. This also I mentioned it. So because many of the students will have the distress. They may think that I may not be understand this concept, and tomorrow I may fail. Right? This is a very serious issue, and how the societal impact that you can see that when people are going to the extreme decision they are taking every day. So is it possible by looking at the kind of a facial expressions, can you identify how much distance is there? Or even we can see that there's a several connect in the silos can be connected. That is, we usually call it connecting the dots. Connect it so that you can able to reduce or infer some new information, so that we can able to identify that a person is a distress, because distress may not be happening at one instance, right? So you need to see the sequence of these tasks which are happened, sequence of the transactions, sequence of the things that happen. So from that, can you able to deduce this one? Similarly, you can see somebody having like a social post in the social media, and those posts will be done in the different social medias. And then is it possible to listen? That's what one of the area when I was in my previous office that we say we started an area called a social listening. Social listening. So from this one, instead of looking at the things after something has happened, extreme steps have happened, like suicide kind of things, it's better that if you can able to have some kind of a the message which are translated, which are actually transferred through the social media, and have the capability of the social listening. So then maybe we may save several lives. So this was actually similarly here in the classroom exercise. You can see that one we can able to help the students for better learning. Any questions till now? I'm just thought of giving some examples of the from AI based education. Any questions are there? No questions. So now again comes to the some kind of a technical technology things, how the different models are. I think there's some comment, because comments I cannot see directly because I am in the full screen mode, that I have to close and then look at it. No, there's no comment actually. Yeah, somebody is actually asking. Hari, yeah, please. Someone raised a hand. Any questions? Any question from anyone? Okay, no, okay, no problem. So normally the AI models, either they could be called it as generative models or can be called as a discriminative models. So that's what you can see. There's AI, machine learning, then supervised, unsupervised reinforcement learning. Then these methods have to be discriminative or generative models, right? The basic idea is how a model will be trained or maybe learned. So normally, if at all it is possible to have a clear-cut decision boundaries, if you are identifying the boundaries, those models we call it as a discriminative models. That means I have suppose I have a people are having the positive sentiment and people are having negative sentiment. If I can able to have some kind of a between the draw a line between these two sets of the points, okay, that is called a decision boundary. So if it all do that, the model does that, that we call it as a discriminative models. Whereas in the generative models, if you try to look at these samples and try to understand those samples, the behavior. So that means that the generative models, the main focus is on explaining how the data was generated. That means it has to try to find the characteristics of this data. Based on that, it will try to say that. So if the models are supporting that one, we call those models as a generative models. What we are doing in this whole exercise is the data is given to us, that is could be an original data space. Now here in this one you can see the blue and red dots. We can say this could be like a separate, these two classes can be separated like this, but very difficult to get a function that satisfies this one, right? It's not like a circle is okay, but we are looking at a screen that we can say circle, but these two different data sets, it's very difficult. That means if the complex data set may be there, one of the data is like this, another data is like this, right? There is a variety of the way that the data can be there, and maybe much overlap may be there. So now use some algorithm or a function or a mapping criteria so that the data can be transferred into the here in the feature space. So where you can able to distinguish separately. So that's what we call it a data in original space we are mapping to a data in a feature space. Once you are in the feature space, then you can build a model and you can do that. So what all the algorithms will try to do is they try to make the data which is there in their own raw data which is there in the original space. We need to make it like a feature space. That's what any kind of algorithm is trying to do. So there are many learning paradigms are there. So I'm not going in details because there may be other sessions which are covering in deep into these aspects. It would be like a supervised, unsupervised reinforcement, self-organization, like a deep learning kind of things. So now, just look at another perspective of these things, how it happened. People started with the process automation, which I mentioned, like a business process will be there. Maybe the series of the tasks, which I will actually do the automation. Like maybe you may be seeing the railway reservation system, right? Or you may be seeing in the supermarket billing system. These are like a automation of the business process. So where you have a business workflow, that is a process workflow, and you have a data, and then we build a kind of build a model, build a system, not a model, build a system to automate the processes, right? This is like a business process, and we're doing that's we call like a process automation. Now you just look at nowadays, if you're booking the train ticket, there is also be if it has the ticket, there's no vacancy, that is, there's a waiting list, and it gives immediately some probability, right? So probability of how much you have a confidence that it will confirm or not. So you click that, you will get a probability. That way 70%, 80% they're selling. That means while booking the ticket itself, can the system can provide you saying that one, what is the level of confidence that you have for confirmation, correct? That means it is trying to aid for decision making. So that's what the models, which are the AI and ML models, is trying to place to help the prediction or some kind of a classification, right? Then in the case of generative AI, then what we are doing, we are trying to supplying some additional information, because the models are already pre-trained models, and then we are asking something what we need. That's like a prompt, right? That is helping us to generate the text, images, and videos, and so on. But in today, in the agentic AI, now everything is like agents. Why agents? Remember that whenever we talk agents, means agents are having like they have a self-learning capabilities, right? So that means these agents can look at the environment and can change themselves. That means you can generate an event and act accordingly, right? So that means the agentic AI is actually trying to come out with a plan, and using the data, and based on some kind of events, it will try to act it. So that's what we call, if you look at the structure of an agent, it is having a memory, and it is having a connectivity with external devices like API calls and everything, and it has a process the data on its own, which is kind of useful for taking the appropriate decisions. So, and then that can be after response, you can get you can see that how the response comes from the whole exercise. That's what the agentic AI today is actually helping us. So now all these aspects are actually becoming like a perfect storm for the AI, because we have the transformers today, like LLMs, ChatGPT, DeepSeek, and everything, Gemini and everything. And there is also a technology like a self-supervised learning, because today we cannot say that when I have a very good training data, I can train it, because the LLMs already trained it, because we need a additional training for fine-tuning purpose. But the model itself should have a self-supervised learning mechanisms. And then we have a huge amount of the computing power today, because people are talking about the systems like earlier we usually talk about the CPU systems, now the GPU systems, then the high performance computing systems. Now we talk about NVIDIA kind of things, right? So high-end systems are there. So all the things are actually making a perfect storm for the perfect storm. So that's what you can see the changes how they drastically happened for the last few years. So generative AI, powered by the large language models, offers transformative possibilities across different sectors. It could be like a healthcare, education, hospitality, finance, banking, journalism. There are many things, right? So in almost each and every area, they're working. So now it is not today. We cannot say that AI is only with some kind of a few disciplines. So it is there in each and every domain, and everybody is actually use these AI techniques. So now you can see the how many parameters that like this ChatGPT kind of things was making about 540 billion parameters and different tasks. Okay, there are many of the tasks like summarization kind of things, language understanding, then fun kind of aspects, and even to have a machine translation, that means from one language to another language. Then the common sense reasoning, which is very difficult to model it. That if you look at the logical forms, particularly for common sense reasoning, is very hard. The people are actually common sense logic means that is the human way of inferring, right? The reasoning aspects. So now you can see the language models, how they are generated. And you may surprise that one you can see, though we are actually seeing this one in the letter space, but this it started in 1966. You just understand that on how the innovations are started. The kind of ideas were there, but they may not able to make it the more practical because of one or many aspects. Okay, so IBM when actually done the Jeopardy game, many of you may be knowing it, right? The Jeopardy game. So they actually started with the gaming kind of aspect, but later they made a lot of revenue generation, everything. Even the blue chip, during the time they have a how playing how system can play a chess, right? With the Caspro, they actually had as a game, and then the system was actually won. The AI agent has actually won the things. So in that way, there's a lot of AI build agents are there for a long time, but it became like a popular when the GPT comes when actually BERT was launched. Then researchers actually thought of many things can be carried out with BERT, but at the same time, like Google actually has come out of the many other things like a the GPT kind of environments and Lambda kind of things. So many of the today like a DeepSeek, right? Of course, 2020 it's old picture, but in 2004, 2005, and 2026 now, the many of the things are happening. So this is another way of looking at the evolutionary tree and many of how it is happening. So this is like a now BERT and bots are becoming more popular in the research, and people are using the GPT. That's what the GPT is also be increasing. New GPTs are coming up. And there are a lot of things are happening in the software design. As I given another example, that one we have a designing the for a project, big project, which usually takes like a 3 to 4 months. People are now doing within hours. That one. And just look at the way of that organizations are looking for. And this is actually I took from the Amazon Industry Solutions, and they have at the bottom level you can see the data. The data could be like a relational or unstructured data, and even the data could be like a IoT data sets, right? IoT data sets like streams and everything, and the data needs to be ingested. Data needs to be ingested, and then to be managed, and then you get the insights, right? And then these insights are useful to serve for the applications, and again application will generate data, right? Application will generate data, and then you can see you can have the edge computing, cloud computing, and people are working on from the software development side. They can have a DevOps, and then people are working with the machine learning with they call it ML ops. Now people are calling it data ops because they want to give a lot of importance to the data. Because even though if you have a high-end algorithms, maybe very complex things can be handled, you have a good algorithms. Unless you don't have data, we cannot do anything. Right? So that's data is actually more important. So this is like a data ops is also coming up. So people are working in the like a DevOps and ML ops. Now people are moving towards the data ops because this is like a change. Okay, this evolution is happening. Many of you may be knowing. Earlier we talked about like a NLP, that natural language processing. Now people are talking about natural language understanding, and then we are thinking about natural language generation. Right? This is things. The evolution is happening. So now, if any organization which was more complex things are there, and without any AI support, helping these things are very difficult. Now, even if you have a cloud, suppose you take Amazon cloud, maybe Amazon may be having the thousands of the systems, right? Now, if suppose a particular node is down, and how to identify that node in a humans is very difficult, right? And the task handled by this node has to be shared among the other nodes, and has to be allocated to the other nodes. And whenever this node is become live or maybe active, then it has to take back that one. Right? All the things should happen seamlessly because the end users may not be knowing what is happening there. Right? So for that, the AI actually really helps there. And of course, in the same time, from the database side, also a lot of evolution is happening because now people are not looking only the data in the homogeneous data. The people are looking at the heterogeneous data, and then you should have a lot of wrappers need to be written to have the data. Because when you say I can develop the intelligent cannot come from the single source, right? It can come from the multiple sources, and that's why the new technologies are coming up. The data, structured data, unstructured data, and further to understand, you require a lot of metadata, and you have a multiple data pipelines needs to be drawn, and then you can have a data pipelines, complex data pipelines, data warehouses, and then data fabric. So this is a current one which currently I am working focusing more on this data fabric, where we have a lot of data sources. Even recently we have attended one of the thing where we have a government is having a lot of databases, data things, but they are actually independent. But for the particular thing to identify, though the data is available, they don't have a common infrastructure that can able to capture the requirement of information. So that's what that we are working on the data fabric side. And this is like a complete landscape which you look at it. What we have seen earlier is like a descriptive analytics, predictive analytics. Now people are talking about the prospective analytics. This was like the thing is, though many people call like AI and AI research and everything, the main idea is it is not enough to give the insights, but they must be actionable. That is more important. If it's not actionable, there's no point of having that insights. So today that AI anything was there, we have to say that yes, it will try to provide the actionable insights. So what is the need of the hour? So it is actually whatever business process are there for the automation, we need to embed analytics into that one. That AI is supposed to be part of that. AI is supposed to be handle all this kind of a business process. So earlier system should be like a reactive. Now we have to use this AI is supporting like most of the things like a proactive. That means it has to be know very early. That means it can be give like early warnings or early signs for many of the things. Correct? Even the education, some of the examples we have considered in the education also. Correct? Then the real time to moving to right time. This is actually another important aspect. Most of the times we may not we give a lot of importance to the real time, but what is exactly important is the right time. That means when I need, I should have that. It's not that I done a real-time analysis. Okay, real-time analysis may be good, but have you actually given the data when the insights when you need it? That's more important. When you seen in the data fabric, though I quickly covered that one, but you can see the data is distributed, and then if you want to do the analysis of that one, you need to bring the data from the multiple nodes and then come and take it. Rather than, can you send the computation to the data itself? So computation where the data was there, so that it is done fast, and then aggregate the information. Okay, movement of the data is very difficult, particularly with respect to big data, because we are talking about the gigabytes and petabytes of the data. Right? If you're moving from the one, it will be takes a lot of time to making here and applying the algorithm. It maybe takes several days also. Right? So that's why people are looking at the distributed parallel computing, which was earlier to be done. Now they're looking like a edge computing or edge AI kind of things. So there are many challenges will be there. The first thing itself is are we identify the actual problem and then formulate the problem. And once you formulated, we need to look at whether we are actually accessing the right data or not. And some of you are asked the question is the right question. That is if it's a garbage, there's no point to use it, right? So that means another challenge is identification and accessing the right data, because we cannot say that some junk data you take and then do the analysis and say, no, I have done it. So rather than, you have to say that once you have formulated the problem, then you have to identify the right data. Then you can build model on the right data. You will get a good prediction. If you build a model on the junk data or garbage data, your predictions will be unpredictable. So then the data quality, and then of course understanding the source of the data, all the things are important. So that's why today we are looking at most of the aspects of the AI. But there is one more thing is there today. We want to, though we have historical data and training data and all of this we talk about, many of the real world problems, we don't have the data, much data to learn it. So that means we have to get the data. We need to know the data from the unknowns. Right? Unknowns. That is the more important and challenging. So that means nothing was not known, but you have to work on that. You should give the information. You should get the intelligent enough to do that work, right? See, that's what known from unknowns is another buzzword which newly started particularly with respect to the AI ecosystems. So that's why defining feasible problems and coming up with reasonable ways of measuring solutions is one of the challenging aspects. Now there are many of the words were there with AI. So some of the things I listed, but there may be many things were there. Purposeful AI, because what are the AI should be actually useful at the end. Responsible AI, that's what the ethics and everything people are talking about. Ethics and everything, that should be biased. It should not be biased towards like AI should not be biased towards many of the aspects like religion, culture, right? Should not be biased. And explainable AI, because today's systems are black box models, so there's no reason out of that one. Because suppose you're solving a problem, you apply deep learning algorithm, and you may get a result, and luckily you may get several times good results. But suppose somebody asks you that how you got this result, can I believe it? No answer. Right? We cannot do, because it's a black box. How it learned, we do not know. How it is producing, we do not know. But is it possible to provide some kind of explanation how it was done? That's what explainable AI. Then cognitive AI, that is more kind of a cognitive reasoning things. Energy efficient AI, because then you can see that AI actually also be run on the systems which are maybe a lot of technologies were involved. So can we have an energy efficient AI? Similar, if you look at in the Google Maps, nowadays you will get a multiple alternative routes, and sometimes they can say which is like a faster lane, which is like a slower lane. But now people are looking at, can I have a kind of where I can have a green pathway. That means I want to generate less. I want to consume less carbon. That means not consume, produce less carbon things. Can you find a route? That green routes that we usually call it green routes or green pathways. Can you find out that one? That means suppose if you have a road, you can go faster, but may not be much. So you are doing a lot of pollution, right? So that's why people are looking for the green routes. Similarly, for each and every area, they're trying to find, can we have energy efficient systems? Then embedded AI, we discuss a lot. And this conversational AI, this is actually many of the each and every industry is looking for this kind of a conversational AI because they want the call centers or the kind of a client facing support, everything they can able to replace with this conversational AI. Right? Then human centric AI. So that means the human in the loop kind of thing, right? The cyber physical systems where it's coming up. Then of course ML ops and everything. So there are a lot of trends are happening in the AI. Maybe I will stop here. Can we have any questions? We can take a few questions. And then. So this is like a AI will recognize us even if we don't recognize it. They say that no, I don't want AI kind of things, but of course the AI will come and sit in our pockets. There are many applications out there. Maybe I will skip this application. So some of the applications we are doing at our institute, in our institute. So this is what we are developing, some kind of LLMs, how it's using with respect to RAG, summarizing. This is not our work. This is just taken from the generating PPT from using LLM, medical note summarization, cross-model retrieval, because whenever multimodal was there. Right? So how you can develop a bots which are more responsive bots, because a lot of ontology required, because understanding the domain is also be more important, which can be given through ontology, the relationships and everything. So this is like a question and answer systems, because in the medical domain, in the education systems, it may be more important. Suppose if you ask a question by student, can it be get a response? So how best that we can able to generate. So some of the things which are our own innovations like a tree bot and everything, we have done it. So this is again a multi-stage QA framework, the question and answer systems, multi-turn Q&A. So because people are looking at multiple terms, and then because sometimes what will happen is you are going on talking, you are interacting it, but suppose understanding the context is more important, right? That's why we started like a in context learning. That is more important. In context learning. So there's a virtual agents. So these are the things which we are working with some industry work. So I'll stop here. If you have any questions, I can take. Any questions, please? If there are no questions, then thanks for everyone. I hope thank you very much. Thanks a lot. I'm not sure whether I bored you or in the first session itself. Maybe expectations may be there.
It's over, sir?
Yeah, over.
Okay, sir. Thank you, sir. Thank you.
Thank you.
Thank you, sir.
To start the next session at 5 o'clock.
Actually, there's a gap is there in between, so I didn't give gap because I have some
Okay,
other.
sir. Okay, no problem.
I got
Sir.
to finish early, so.
Okay, sir. Thank you, sir.
Thank you. Thanks a lot. Thanks for your patiently listening for last 2 hours. Thank you.
Thank you, sir. So the next session will start at 5 o'clock.
5:15, ma'am.
Madam, 5 o'clock.
5 o'clock. Okay, ma'am. Thank you.
Yeah, madam, 5 o'clock.
Is there attendance, madam, sir? Good evening, dear participants. Going to start the session. So in this session, I would like to discuss about artificial intelligence and how artificial intelligence can be utilized with respect to social impact of the society. First of all, we need to know the particular component, what way we are going to design any applications with the help of artificial intelligence. So we'll see. So with respect to component, so in terms of introduction point of view, and then we'll see history and how we can develop the intelligent system and what are the foundations are needed to develop of any artificial intelligence system. And we'll see the applications, and particularly there are multiple components are required, like development point of view, and various current trends are also there. So introductions point of view, artificial intelligence, I feel discussed like it's abbreviated in terms of AI, and particularly this field is more related to computer science. And the development point of view, the developing system is capable to perform a task like we can do with the help of human intelligence. So we can say here artificial intelligence encompasses like many tasks, like to solve any problem itself, a problem solving component, understand the various languages in terms of natural language processing, and we have to learn from the experience point of view, like human learns from the experience how human can be actively working in the field, and it will be adaptive component. So the same way the adaptation to that will be provided to niche situations, so that adapting component would be given to the machine. So AI basically perform the various tasks, start from the problem solving, understand various languages, and with respect to learning from experience, and that experience will extend with respect to various new situations. Let's example, we can discuss one example like self-driving car or driverless car. So in the driverless car, the component is required like a particular vehicle or particular car or particular automobile design will responsible in terms of intelligent way. So what do you mean by intelligent way? Like how we have understood the human learning. So how human learn? So basically human learns from various examples, and it will improve by the experience, and then it will be able to solve the problem in the future when it will experience new situations. That means the possibility of the new expertise will be able to manage by the human also in terms of developed learning. So that learning, because of the cognitive capability of the human brain, would be managed by the human visual system. So we can say same human visual system would be given to the like machine, and the machine will recognize particular object in a self-driving car or recognize particular platform in terms of images, in terms of views, and then also we can provide the situation, that means distance of the various object and depth of the various object would be given by various sensors. So here in self-driving car, the capability of the human visual system, or with the capability of the cognitive capability of the system, will be given to the machine, and machine will be able to drive the car in terms of self-driving car. That means without human, the same possibility would be given to the self-driving car. Same way we can get it one of the example, chess playing computer. That means, and when we are playing the real-time chess, the same practicability would be given to the, we are playing with computer, with the machine and how machine will play with respect to human versus computer. And various chatbots which has been designed nowadays. That means whatever the outsourcing services would be provided, for that we have observed that a complete system will be managed by chatbot, and that service will be handled by the chatbot itself. So all these are the examples of artificial intelligence. So we learn from the artificial intelligence. So particularly various dimensions of artificial intelligence would be there, like it will provide you thinking capability, acting capability, and this is the major component of artificial intelligence. That means you will observe that what way human is acting. That means acting humanly, and think like how human are managing all the reasoning, or with respect to thinking rationally, or with respect to acting rationally, and with respect to think as a human being. So these are the dimensions of the artificial intelligence would be there, and based on that we are going to provide the particular solutions for the machine or for the system. So thinking, acting, all these are the components which will be provided like a human being. So thinking humanly, acting particularly rationally, and thinking rationally. So we have to observe by the example, like thinking humanly means the involvement of the human being would be replaced by the computer-based machine or like a robotic machine. So that involve the modeling human cognition. We are going to develop the cognitive capability to the machine. So we are trying to understand, we are trying to develop a model, and that model will be replicate as how human mind works, how human brain works. So as we have seen with the nature of particularly human capability would be provided to the system. So there are two possible ways are there how human being used to find the answer of the questions, like with respect to introspections and with respect to experimentation. So according to experimentation and introspection, these are the two answers would be given that based on that question. So we have to understand other capability of the human being, like thinking rationally. That means it involves the formalizing the inference process. What are the inference process of the particular system will be there. So inference process in artificial intelligence is a process of reasoning and making decisions. That means we want to take the decision based on the available data or extracted data from various sources. And it would be a piece of data which is extracted either from various speech data or various image data or various census data which is collected with respect to healthcare, agriculture, or many places, and it would be finally considered a piece of information. So reasoning particularly involves manipulating all this data as per the defined rules. So whatever the defined rule would be there, well-known defined rule would be given to provide all this reasoning. So we are going to manipulate this data according to well-defined rule. Now we'll see another mechanism which is available in human. That means we want to act like human. So acting humanly, the meaning is that capability of the machines which exhibit human behavior. That means we can say here it will exhibit the human behavior, and capability is particularly needed to be incorporated in machines, to be incorporated in systems, and we may see here act like a human. That means perform like a human. So we can observe in this image when the human are performing some task, like a particular gestures of this girl, we can observe the same gesture would be managed by the robot. So we can get it all this kind of management like natural language processing, understanding of the knowledge representation, and we may able to develop a many algorithm with the help of machine learning, deep learning. As I said, human vision system, particularly we are going to perform computer vision and image processing, and finally we can develop particular system in terms of robotics. So capability is needed to be incorporated in machines or system that act human. So acting rationally is also, the meaning is that what kind of right action would be provided and which achieve our goal. That means it is very capable to handle this kind of activity in an industrial point of view. So once whatever the goal we decided, for that we need to provide the particular right action. And also we have to maximize the goal achievement, and also we can give the available informations about the environment. So we may able to give the available information about the environment. So this is the example. Most of the bionic reflexes, that means various bionic reflexes are available, that is in terms of various sensors are there. We do in our daily life, like regrouping of slipping glass from the hands or removing our hand away from the hot objects. So sudden action would be managed by the our action, and but it will be sensed by the our brain. So like what regrouping of the slipping glasses are there from our hands, or sometimes any hot object would be there, we are removing our hand. So these are the some bionic reflexes are there. We do our daily life, and based on that regrouping of this thing and all this kind of action would be taken. So these actions rationally means doing the right action in right directions with respect to achieve our goal, maximize the goal achievement, and with respect to all informations about the environment. So we may see when we started such kind of research in AI, we can get it the example of Alan Turing. So Turing has developed such test during 1950s, and that is considered as a Turing with respect to Turing machine. What Turing has done, Turing has performed one test, measurement of system ability. That means how system will exhibit the intelligent behavior, and that can be distinguished by the human being. So how human can distinguish with respect to intelligent capability of the system. So but Turing test does not distinguish between thinking humanly or acting humanly. Simply it has evaluated the whether AI system can perform the intelligent capability or not. So however, various AI research and development we have seen, it involved the aspects of the acting humanly, thinking humanly, and also with respect to varying degree, whatever the degree depending on the specific goals and applications. So AI research and development involves the aspects of we have to act humanly, we have to perform humanly, we have to think humanly with respect to various degree depending on the specific goals and application. So at that level, we can see the AI was developed, AI was started, how Turing has continued all this kind of activity, because the basic idea was given by the Alan Turing, and the test of the Alan Turing was very simple during that time. That means one test would be there, one computer will be there, and one human responder will be there, and they are playing. And particularly, there is a question and answering session will take place. So human judge will engage in a text-based conversation with respect to both human and machine, and they will decide they to believe and the to be human. So if judge will be able to distinguish the human and machine based on the conversation. So machine said to pass the Turing. So that means the situation is like the judge is not able to distinguish by human and machine of that conversation. Machine is said to pass the Turing test. That means machine has almost reached to the capability of human responder. So interrogator or questioner will be a third player, will take part in this activity. So the idea of the Alan Turing test was, it was provided one system, that in that system human judge will engage in a text-based conversation, both cases like human as a computer, as a human responder and as a player, and machine would be a computer as a player A, and they decide by the, that means they believe as a human. So if judge is unable to distinguish between the human and machine based on that conversation. So machine is said to be the pass the Turing test. We may see that how Turing test conversation took place. So interrogator is very limited concept because it's using the response from the written questions to make the determination. So conversation between interrogator and computer would be like that. Interrogator, are you a computer? Computer will say no. And then again multiply one large number another, and after long pause, incorrect answer. So like 8 such number, after that 20 seconds of the pause, it give a answer. So by this way, the Turing questions will be answered. So according to that, we recognize, that means how Turing test has verified. So we started research. We can see in history point of view of AI. So AI has started like in 1950. Once we can see the Turing test. So Turing test is a method for determining the intelligence of machine. Then after that, the term AI came in the field. So like that, the first term AI, artificial intelligence, basically used for first time. After that, 1960, ELIZA, one of the first chatbot was developed. It simulates the conversation as a psychotherapist. After 70s, 80s, AI winter, after the boom of early research, there was a pause. So 97, Deep Blue, that means a one chess computer was developed that win against the chess world champion Gary Kasparov. So 2011, we have seen the intelligent speech assistant was developed, integrated into iPhone 4S for the first time. 11 itself, Watson, it's a one supercomputer. Watson wins against the two human rivals in the quiz show Jeopardy. So 2014, we have observed that Alexa, that was the virtual assistant developed from Amazon, that moved into the continuous in the markets. So related 16-day that robot had to be reused after a short time because it's risk and remarks. Related to 17, AlphaGo, it was the development by the Google and they beat the world champion in the game. So related to that, we have seen like currently we are getting generative AI, ChatGPT, all so many research are carried out. So European Union established the guideline for deadline with ethical conditions in AI. So all this kind of way we can observe artificial intelligence would be divided into two types, type 1, type 2. So in type 1, as we have seen earlier days, narrow AI, general AI, strong AI. Now we have seen type 2, which is related to various machines like reactive machines, consist of limited memory. So we can say that limited memory and theory of mind and self-awareness. All these are the points comes under type 2. So narrow AI means we can see the example of Alexa. So narrow AI is also known as weak AI. So weak AI is particularly designed and trained on a specific task or a certain narrow range area. So these narrow AI systems are designed and trained for a purpose. So particularly these narrow systems perform their designated tasks, but mainly lack in the ability to generalize the task. So like personal virtual assistant, it's like example Alexa, Siri. These are the recommendation systems, or sometime image recognition software and other language translation tools have utilized. So we may able to say here Alexa, we can ask to the particular player, that means play that system. So this system can play by the human are asking to play. So that way Alexa, what is the status of the traffic from to home? Not to be answered. Only Alexa will assist related to this music player only. So play this particular player, play, and then it consider as a weak AI, narrow AI. So where narrow AI designed and trained for specific tasks only. That is narrow range task. According to that, it is designed for that particular. So particularly there is a main problem here, that is a lack of ability to generalize the task. So personal virtual assistant, all and recommended system all comes under this category. Now, generally, if you'll say general AI, known as strong AI, particularly that refer to the AI system, which consists of human intelligence, and also it has the ability to perform various tasks. Like system have the capability to understand, to learn, and to apply across the wide range of tasks, which are similar how human are able to adapt and to perform the various tasks. So in general, artificial intelligence, it's a remain theoretical concept, and also now AI can achieve this goal of intelligence. Super AI, that is also super intelligent AI system, sometime it will surpass the intelligence of humans because it creates with the help of problem solving. It consists of creativity. It provides the overall ability to perform like human. Super AI develop emotions, sometimes desires, need, and belief of their own concept. So they are able to make a decisions of their own and also solve the problem by their own. So that is the types of super AI. So which is 4 types of AI based on the functionality. So we may divide in terms of reactive machines, limited memory machines, theory of mind machines, and self-awareness machines. So basically, this is the most basic type of AI machines. Do not have any strong, it cannot use the past experience to manage the future activities. So we may consider it observe the live actions and react to them. Similarly, limited memory machines have the limited memory and it can store information for the limited period of time. Let's example self-driving car. Self-driving car consists of various kind of camera, which is related to visualize information of the road, of the object which is available on the road in terms of RGB camera or in terms of depth camera, LiDAR camera. So data stores include the current speed of the other vehicles, distance between vehicles, speed limits, and route navigation. All these are the major information which is more important, which is available under the limited memory machine. Now we'll see the theory of mind machines. No direct use cases are currently available. Only the machine would be able to simulate human behavior. So we'll be able to manage by the researcher. Researcher will understand what is the human's feelings are there, what are the human emotions are there, and that could be a replicate to the machines. Self-awareness machine also one of the type of machine which is available under the functionality. This machine also no practical models are available so far, but this machine will be able to make their own decision. So basically these machines comes under the adaptive because will think and relate things just like a human being. So these are the particular concept has arrived under the AI based functionality. So now we can divide the complete artificial intelligence system. So artificial intelligence system, under that we have two subfields. One is machine learning. So machine learning concept which is required to train the system and to design the system without being explicitly programming. And then we are going to mimic the human brain, which is designed by the concept of deep learning. That is a deep concept of learning is also subset of machine learning. So here machine learning is a subset of artificial intelligence. We are going to enable a system or a machine which automatically will learn from the data using various statistical features without being explicitly programmed. Now the deep learning also subset of machine learning which uses the multi-layer neural network. Multi-layer neural network, and that is called deep neural network. And basically we are going to simulate the complex decision-making system of the human brain. Sometimes deep learning power most of the artificial intelligence applications in our lives today. So this based on now in deep learning, now we have observed that ChatGPT and other concept, which is the part of generative AI. That means we are going to generate the artificial informations or which is resemble to realistic information. So synthetic data set would be created in terms of healthcare, in terms of agriculture or various places.
So finally, the system would be realized as an intelligent system. So in intelligent system, which is available in artificial intelligence, and these are the technologies designed to perform the tasks that usually need human intelligence. As we know that how human intelligence, because of the cognitive capability of the human being, human are able to understand the concept with respect to learning. So as we know that how human learns, so that means human learning will be the part which is available by cognitive component as well as by using of human vision system. So systems are used in many area, like we are deploying the intelligent system in a robotic area or in data analytic area, or it is very crucial for advancing different industrial component. So let's explore the what intelligent system we are using. So it consists of main parts of the system where they are used. So how they might be developed in the future. So an intelligent system in artificial intelligence technology equipped with the capability to gather the data, to process the data, which make the decisions or perform the action based on the data. So very clear definition we got here for the intelligent system. It is part of technology in terms of artificial intelligence. So if you are equipping the AI in a system, so AI is whatever the system capability would be there, it will enhance the capability of the system with respect to data collections, which collected data from various sensors, from various sources, and we need to process the data and we will make the decisions like how human will be able to take the decision. So same, we are going to perform the action based on the data. So at its core, intelligent system mimic the cognitive functions of human being. As I said, cognitive capability of human being will be replicated at this level. So it will make the system intelligent. So as we know that how human learn by using of various experience. So learning from experience. So learn by examples, which is the part of machine learning. So we are training to the machine with respect to available data, and machine will learn from the experience. And also machine will understand various complex concept and as well as various problem solving criteria. And finally, by all these component actively working to make the decisions. So same way we are going to conclude at the human level also how human cognitive capabilities for performing, like learning from the experience, understand from the various complex concepts or data, and various problem solving, and based on all these component it will make the decisions on. So finally we receive the final component which will be helpful to design an intelligent system, or this intelligent system will equip with the AI. So which AI will help to take the decisions with the intelligent level, and it will become a like human level. So reasoning is one of the major component to make a system intelligent. So reasoning involves drawing conclusion based on the evidence or based on the argument. It includes inductive reasoning. What do you mean by inductive reasoning? Because the reasoning will develop a general conclusion from various specific examples, and deductive reasoning which applies general principle of specific cases. Now, as we know that it's the system equipped with the AI because of learn from the experience that will be given by learning. So learning is the long-term process. Learning is long-term process when we acquire a new data, new informations, and we can modify the existing knowledge. We can improve the existing knowledge. So yesterday we have learned different things. And today we are learning different thing because we are modifying existing knowledge today. We are improving our skills. We are improving our behaviors. So it can happen through direct experience or indirect experience, or observations or instructions, or it is essential to adapt to new situations. So that the same situation would not continue tomorrow. So tomorrow we'll have the new situation. So today's knowledge, today experience, today instruction, today observations, we'll have to deal with the new situation also. Now the next component is perception. And perception is one of the important component which is available from cognitive process. So cognitive process will provide interpretation about the information, organize our sensory information, like we have seen what are the sensory information which we are getting to the cognitive component, data which is available to the brain from various sensors. So sensory information which allow to understand the environment. So it's allowed to take the sensory data to various sense organs and it will make the sense of world around. Now, as we are talking, as we are understanding, as we are like interpreting that particular information which is available in terms of linguistic intelligence. So linguistic intelligence is also very important component. That means it has provided ability to use languages. Languages, that means we are reading some language, we are writing some language, we are speaking some language. So we are using language, both written and spoken component effectively. So people with high linguistic languages or people with high linguistic intelligence are skilled at 3 levels: reading, writing, and also they may able to tell a story, they may able to memorize the words also. Sometimes they may memorize the words and it will be helpful for linguistic point of view. Finally, the component which will be provided to solve any problem in a system to make a decision, that is given by the problem solving. The problem solving is nothing, it's the ability to process the information and find the solution. Let's example y equal to ax plus b. This is a straight line equation, but this can be given to the machine learning model. That machine learning model will solve as a regression problem. That means that 5 years after that, what will be the salary of the person will depend on the component A. So ax plus b. That is the same component which we have given y equal to mx plus. So that means x value would be defined. What will be the salary after 5 years? What will be the salary after 10 years? So that means problem solving has the ability to process the informations which we have to compute the variable a and b. So find the solution of complex or challenging situation. It involves identify the problem, generating the potential solutions, and effectively implementing the best solution. Now we finally reach to learning component in an intelligent system. So we can now define the learning component with respect to how we are going to teach the machine, how machine will be able to learn with respect to available data or with respect to available information. So we are going to divide the learning methods in an intelligent system into 3 types. First, supervised learning. Second, unsupervised learning. Third, reinforcement. So you may see that supervised learning, when supervisor is available, teacher is available, that means we are going to teach the machine with the help of labeled information, labeled data. So in that situation, the supervisor teacher will teach the particular information with the help of label. In unsupervised learning, there will be no label data, no label information would be available. And the last technique in the learning mode, which is the trial and error method. That means we are going to teach to the machine and we are going to show the result. So here in supervised learning, you can categorize, you have seen this kind of informations in your daily life by using of supervised learning. It's a type of machine learning method where algorithm is available trained on labeled data set. So method will teach by the label data set. We can see here label data which is available. Label has given according to this data set, it consists of 3 different category of data which is available: elephant, cow, and camel. So label given. So in this approach, input data is paired with correct output. So every data will consist of correct output and algorithm will learn to map input to the output by using of minimizing the error. So once you reach to elephant as elephant, error would be 0. camel as a camel. So we are going to perform this processing, and based on that, input and output will be mapped and reduce the error. So it's commonly used for tasks like classification and regression. So which in the particular diagram, we can recognize this is the data which is available in terms of label. So label data set is available, and here this data set consists of training data set, and the teacher is available to teach. This is elephant, or this is camel, this is a cow. So based on the desired output also available, then we are going to develop an algorithm. Algorithm will teach to the machine, will train the machine. After training, while processing, it will produce the output, and this output will match your accurate output which is already available in label. So that means this approach, input data is paired with output or correct output, and algorithm will learn to map the input to the output by minimizing the error. So it's a commonly used task like classification and regression. Now we have seen example of various supervised learning. Let's see email filter. This is a common example. We are getting the emails in the Gmail account or different account. In that account, we have two types of inbox will be there and spam will be. So supervised learning commonly used in email filtering. How our email systems are filtering incoming mails, which will available in inbox or which is available in a spam or leggy mail. So machine learning method is going to train using label data set that containing both type of data, which consists of inbox data, which consists of email data. So algorithm will extract the relevant information for each email. So sender information like subject, message, body, so many things are there. So we'll learn the label data set to identify the pattern and relationship between these features, and corresponding labels will be there. So once we are training the data, algorithm can use the extracted feature to predict the label of new or unseen images. That means after training is over, the algorithm has trained will be able to recognize without any label data, that is unseen data. So email is predicted to be spam, so it will go to spam. Email has been predicted inbox, it will go to spam. It will go to inbox. So it will learn the particular data based on the pattern. So what kind of pattern of the mail would be there? What are the relationship between? So same way, if you are getting the call, like a spam calls are also coming. So how software will predict? That means they are continuously getting call every day related to various agencies, various advertisement companies, or many. So based on the nature of that company, based on the call of that company, continuously applying that company, all these features, corresponding call will be defined as a spam call or not. So it filtered would be there, that filter will be able to solve all this kind of thing and save as a user inbox or spam. So we have one more example, credit scoring. That is one of the important example nowadays in available in like many software like Bank Bazaar or our UPI system which we are using, like in Google Pay, we can use in GPay, you can get it our credit score. And this credit score is particularly depend on how many loans we acquired, how many credit card we have, and when we are submitting our amount to the credit card. So credit score will be part of supervised learning to predict credit worthiness of loan applicants. So label data set consists of the example of past loan applicants, their credit history, income, employment status, and many other relevant features will be there to train a machine learning. So algorithm will learn to recognize the patterns and relationship between these features and their corresponding labels. So such whether we are eligible to that loan or not, so we will be able to pay a loan or not. All these features are important. So once we have trained, algorithm can predict the loan repayment likelihood of new loan applicant based on their input features. So the person having poor, they are not eligible. Person having average, they are not eligible. Person must be having good or excellent this credit score that will be identified by the various features. And that label data set consists of all these past loan applicant will be there, credit history would be there, income would be there, employment status would be there, relevant factors. So algorithm will learn all this and recognize the pattern and relationship with these features on. And corresponding label also would be predicted whether or not loan was repaid or not. Once trained, algorithm can predict loan repayment likelihood for new loan applicant also based on that input feature. Likewise, we have another learning method that comes under unsupervised learning. The same example of input raw data, which consists of elephant, camel, and cow, but there is no label is available. Now, with this data, unsupervised learning will help to recognize unknown output. There is no label would be given, no training data set would be provided. So, unsupervised learning is a type of machine learning method where algorithm is trained on unlabeled data set. System try to learn about the pattern, structure from input data without explicit instruction would be given. That want to predict. Then algorithm will be able to identify in terms of clustering, in terms of dimension reduction. So approach is used for clustering, dimension reduction, and anomaly detection. So based on the cluster means identify the same features, the same point which is near to that area will be covered one cluster, that near to another area which will be covered under another cluster. Based on the clustering will be classified them, but there is no predictions as a target level would be there. We'll see the examples of recommendation engines we are using currently at our daily life. So like past purchase behavior coupled with the unsupervised learning can be used to help business discovery. So that data trains they could use to develop effective cross-selling strategy. Like customer segmentation. So interesting buyer person profile can be created by using of unsupervised learning, and then help to businessmen people to understand their customers' common traits, purchasing habits, and we are to enable to align their product more accordingly. So likewise, there are other example would be there. So in reinforcement learning, so it's a type of machine learning where particularly one agent will involve, agent will learn to make the decision by performing the actions, and which the action is available in an environment to maximize some notation of cumulative reward. That means the output will be penalized or rewarded. So agent will receive the feedback in the form of reward or in the form of penalties. So based on that action it takes, so allowing to learn optimal behavior over time. It is a commonly used area like robotics, gaming, autonomous system. So in this reinforcement learning, that approach is considered as a trial and error. That means we are trying and getting, if any error would be there, trying to improve it. So let's example, we are going to teach the machine apple, but we have not shown apple, we have shown different object. That machine will understand and again give the reinforced response. This is not apple, this is different. So again the machine will learn and finally will show that because of the reinforced response, the machine will be able to learn that kind of behavior object. So agent will connect to environment, will be considered as a reward or will be considered as a penalty, and again it will improve, again will. So this is the feedback system. So like in that action, maximize the sum notation, cumulative reward, agent receive the feedback in the form of reward or penalties based on the action, in allowing to learn optimal behavior over the time. So it's a commonly used application which we are using in robotics and autonomous system. So we have various other example like entertainment and gaming. So reinforcement learning has master gaming like Go, chess, Dota, or many other applications. So it used to develop an intelligent, realistic game AI, which improves the user experience. Another application area is robotics, autonomous system. So reinforcement learning allow the robots to pick up skill like navigation. That means robot will learn, will identify particular navigations by the feedback mechanism. Object identification, manipulation. It's a very essential component for development of autonomous vehicle, driverless car, drones, and various industrial automation. So finally, we can get it the various applications of intelligent system, like in the field of robotics, we use in manufacturing, we can use in healthcare, or various service industry which provide like assembly, surgery, or customer services by the like replacing of chatbot and other thing. So data analysis, which will be helpful for extracting insight from large data set in the field of finance, marketing, and research. Natural language processing, which will enable the machines to understand and generate the human language, which is applicable in chatbots and translation services. Computer vision, which is replicate for human visual system. Machine will learn from the image data, interpret, understand the visual data, and use like autonomous vehicles and facial recognition. And various expert and recommendation system, AI will help to emulate the decision-making capability of human expert, which is helpful in medicine and financial. So what are the development point of view you want to develop the AI? These are the basic foundations are needed, that you should be very enriched in the mathematics, you should enrich in the neuroscience, control theory, and linguistics. So we'll discuss all these points one by one. I'll just take a 5 minutes break, then we'll continue.
A the object that orbits or circles around a large object is
So now we can continue. So related to when we want to develop any artificial intelligence system, so we have already seen that applications of intelligent system, particularly with respect to robotics or data analysis. As you know that if you are developing any applications for robotics field, in the robotics field mainly developed for manufacturing or healthcare or like telemedicine or various service industry. So they are mostly providing the solution for assembly or particularly for surgery. So automated surgery with respect to robotics or customer services. All this kind of application comes under this area. Now data analysis also, we are getting the data from the various field like financial data, marketing data or research data. That data which will be big data, it will become a big data. Later we are going to provide the solution for machine learning, deep learning to make a decision. Same direction, NLP will enable the machines to understand various language or particular will generate the human language. Like we have seen nowadays multimodal technology. We have seen various movies which are available in one language. Now it is available in multiple language. Together with subtitles also available. So that is the particular example of AI will help to understand and generate the particular language in a chatbot or translation services. Also, similarly, when we are talking about image processing and computer vision, where machine will understand about visual information, visual data, like example of autonomous driving car. So camera will continuously monitor information which is collected data from the road, and also which will provide the information which is available on the road, like a object or in terms of pedestrian, in terms of vehicles, in terms of known vehicles like animals and other factors will be helpful, or also signboards which will give the direction how the particular vehicle will drive on the road. So same way facial recognition or emotion recognition would be helpful to get the facial data, and it will provide particularly solution like a login without password, login in the workstation, login in computer by the facial data, or replacing to biometric applications related to same direction. Facial recognition will provide the facial data to log in industry also. All these kind of application would be the part of computer. Same expert system, recommendation system will emulate the decision making process for human expert, and which is helpful in the industrial point of view or medical or financial. So finally, when we want to develop any AI system, these are the foundations are needed. That is, people must be very expert in mathematics, people must be very expert in neuroscience, people must expert in neuroscience according to control theory, and linguist, which is very helpful with respect to language. So we will see the foundations. Mathematics, we have studied about mathematically various logical methods like Boolean algebra or fuzzy logic. So Boolean algebra, which is the part of mathematics, under that various values are reduced to either true and false or in terms of 1 and 0. And also we have designed various digital circuits. So digital design, when we have studied about digital design, deals with numbers. And numbers also would be identified in terms of like binary or in terms of octal, hexadecimal. So it deals with the variable, and particularly that will have one or two possible values on. So purpose in terms of artificial intelligence, the Boolean logic is very crucial for AI, particularly representing and manipulating the binary relationship or provide the decision making one. So it forms basis for logical operations, like we can perform various logical operation, ending operation, ORing, NOT, and XOR, which is main fundamental programming and AI algorithms. So further we have extended towards the fuzzy logic also. So fuzzy logic is also formed in the form of many value logic. That means we are extending the
extension of the 0, 1 between 0 will reach to 0.25, 0.5 and 1. There is a range where the truth value variable may be real number between 0 and 1, but it allows the degree of truth. That means at what level you are going to consider degree of truth. That means in between small and tall, there is a limit would be there, large, tall, or lowest, small. So it allows the degree of truth rather than strictly true and false value of the Boolean logic will be there. So in Boolean logic is strictly followed under the 0 and 1, but we are extending between 0 and 1, 0.25, 0.5 and 1. Between these are the degree of truth would be there. So this is very helpful in a purpose of AI because fuzzy logic is used in AI when we are dealing with uncertainty. That is the uncertainty and imprecisions will be there. So it enables the system to work with approximate reasoning. That means what are the output approximately you are getting, and we are going to handle the situation whether the decisions are based on the ambiguous information or without that one, or vague information. So fuzzy logic is particularly useful in terms of control system, where the control systems, which is the major important applications would be there for decision making process where input may not have clear cut value. So that is the major important area which we are working. So fuzzy logic has provided the various solutions. So that means which is helpful for computing approach. That means when we are computing approaches are coming, replacing to Boolean algebra to fuzzy logic. So it provides the computing approach based on the degree of truth. So rather than true and false of Boolean logic, which you have seen, and this technique initially, if you see that developed during 1960 by Lofty Jade, in that time it has mimicked the human reasoning. That means human reasoning was there by handling the imprecise or whatever the vague or noisy data was there. So we can see here the value was available between 0 and 1. So it is basically in control system which we have seen. AI is one of the important aspects to solve the problem. So in control system, we are processing data with respect to control level. So we can get it various other examples also, like a natural language processing also. So fuzzy consists of fuzzy sets will be there. So unlike classical sets, which consist of item will be there between 0 and 1, true and false, fuzzy sets have boundaries that are not clearly defined, allowing the partial members. So degree of truth also, which is very important under the fuzzy, because instead of saying the 1 and 0, the value would be there between 0 is completely false and 1 is completely true. But in between 0.25, 0.5 is not completely false and true. So membership function would be there. So 0 and 1 bracket 1, 2 membership function. But 0, 0.25, 0.5 and 1, that is the 4 membership function will be there. So this map data value would be there between 0 and 1 in a particular different function. So if and else rules we are using, the fuzzy systems are using like human, like what human are using, like if speed is fast, distance also close and break up. So these are the requirement of the fuzzy system will be there. And fuzzy system basically works under fuzzifications and defuzzification. That means fuzzification means which will convert the crisp value. That means input value will be there like a precise temperature, precise wine value or various sensors value would be there into fuzzy type value. Like with temperature, it is warm, it is cold, or it is coldest. So inference point of view, we are going to develop inference engine which apply if then rules. Fuzzy input determine fuzzy output. Then finally defuzzifications convert the fuzzy output back to again crisp form or usable control value. So fuzzy logic is very helpful, frequently applied in various applications like consumer product, washing machine, adjusting the water based on dirtiness, or like camera, or like dishwashers. Similarly, in a automotive application, so automotive gear selections, braking systems, or fuel injections in the automobile, artificial intelligence, which we are using, medical diagnostic, pattern recognitions, or many application industry like managing the temperature, managing the pressure, managing the machinery performance. So basically the advantage of the fuzzy point of view, we can handle the particular imprecisions, effectively model complex systems with unclear data would be there. Like human way, we can do the reasoning because rules are very easy to understand. Based on the rules, we can implement the human expertise system. And the system is completely robust because it's a less sensitive to noise and incomplete. That is the mathematically foundation is needed. Similarly, we have the uncertainty, probability theory, model, temporal logic. All these are the probability theory comes under the AI. So probability theory also very helpful. And this is the branch of mathematics where we are quantifying the uncertainty. It provides the framework for understanding how likely various outcomes are in given situations would be there. So particularly probability theory will help in AI because we are using the extensively in probabilistic reasoning, decision making under the uncertainty condition. So when we are developing AI system, we want to develop a reasoning. So we want to model and reason about uncertain situations. And we may make the predictions based on the available data. And also we make the decision and we can optimize the outcome. That is the considering uncertain factor also. So like various technique you have studied in machine learning, like Bayesian classifier. The Bayesian method would be there in probabilistic theories, like a Bayesian network, probabilistic graphical model. Probabilistic programming also is a part of probabilistic theory and widely used in AI tasks like machine learning, natural language processing, and robotics. So we may see that model and temporal logic. So model logic and temporal logic, these are the two kind of logic would be there in a mathematics point of view. So as we know that model logic is a extension of classical logic. That means we include operator that express the modality. Like it's a necessity will be there, possibility would be there. So it's allow the reasoning about necessity or possibility, belief, about the knowledge and other model. And we can use in AI. So model logic is used in AI for representing the reasoning about the knowledge. What are the belief beyond that knowledge would be there. Actions of intelligent agent would be there. So basically it's provide the different kind of statement like it is necessary or it is possible in a structured way. So it enables the AI system to reason about the complex scenario, complex situation, which also involve uncertainty and multiple edges. But in terms of temporal logic, it's a formal system. That means about the same reasoning about the time. Temporal means time relationship between event. So it includes the operator that express the temporal concept before, after, always, eventually, until. So that is also very important in AI. What is the purpose? So temporal logic, which is very helpful and crucial in AI to model about the reasoning, where the time play very crucial. So allow the AI system to specify and verify the temporal property of the program. Let's example, we are considering the video. So video means the frames are coming with respect to time and images will become a video. So there is a temporal property is very important of the program and system. Ensure that correctness of the temporal behavior and also correctness of the temporal plan actions according to we have considered the temporal constraint. So we can consider here scheduling, real-time systems, robotics, intelligent agent system, where the time is very crucial component. Now in terms of other component that is very important, that is part of the AI, that is called neuroscience. So neuroscience also will be required to develop a AI-based system. So how brain will process the information, how our brain works. So information processing in the brain starts from transmission of signal between neurons. So brain consists of millions of neurons and neurons are communicating with each other neurons only. That is electrochemical activity, where the signals are transmitting and receiving from one neuron to another neuron. So neuron will receive input signal under the excitatory or inhibitory condition would be there. So from other neuron, by the sensory receptors are there. So it integrate all these signals and generate the output signal. So how artificial neural network generated with respect to biological neural network? In terms of biological neural network, which you have seen input and output in between multiple neurons are working, considered as a synapses, and other factors are there. So neurons are communicating each other through the electrochemical process, and neurons receive as an input signal and reach to the output. So generate the output signal in between other neurons are considered as a respiratory signal. So another foundations are very important, that is for control theory. Control theory also one of the important aspects which we can understand control theory in AI, which apply in engineering principles only. When we want to design a various system that automatically adjust the behavior based on the feedback. So in control system, we have studied about open loop system, which does not have any feedback. We understood the closed loop system, which consists of the feedback. So based on the feedback mechanism, we are going to rectify the output. So already this kind of analysis which you understood under the control system. So we emphasize the feedback loop which monitor the system state. So current state, next state, current state. So we can optimize the actions as we have seen agent and environment part in a reinforcement learning. So same way the feedback system will monitor the system states and optimize the action for achieving the goals based on the we are maintaining the stability. So AI system which we are using controllers from simple algorithm to complex algorithm or maybe adaptive algorithm. So as we have seen in reinforcement learning, it is very crucial in a robotic application, autonomous vehicles and industrial. And all the system optimize the performance, manage the uncertainties, and also adapt to change the environment. So that means the environment will change through the various adaptive and learning control techniques. And there are many challenges are here like scalability, real-time processing, and also we need to drive the future research. By this way, we can improve the adaptability, robustness of the AI application. So this is also one of the major foundation of the system. Like the last, which is very important, linguistic. So linguistic is a main AI building block. It consists of understanding of language, consists of translation of language, transformation of language, and we have to generate the language. So linguistic in AI is particularly interdisciplinary study of the language. And it is very important with respect to computational point of view. That means computational applications within the artificial intelligence is very important. So when we develop any AI-based system, it involves the applying linguistic theories and methodologies to develop algorithms, to develop models, to develop system. So based on that, we can understand and generate the process of human language. So we know that natural language processing is the major component artificial intelligence. So various key aspects of the NLP will be there, which encompasses the tasks like a text analysis, speech recognition, machine translation, sentiment analysis, and language generation. So linguistic will be very important component in AI, which integrate from the linguistic point of view or computer science point of view or linguist or cognitive point. So machine learning, which will be understand in advance about the utilization of languages to make intelligent systems and to provide the solutions in the intelligent system. So far we understood all these are the major important components are there in a foundation. That means we know that mathematics, in the mathematics we understood Boolean, we understood about the fuzzy, we understood temporal, that is the time behavior of the component, and also we understood the particularly what way we have designed the biological neural network. That means biological neural network is the one of the important aspects under the neuroscience. And also we have seen in terms of control theory, this is also very important for the AI foundation. So biological neural network, as we know that what is the structure of human brain would be. That means we understood the, in particular, neuroscience point of view, biological neural network. Based on that inspirations, we have developed the artificial neural network. Then we have implemented convolution neural network. Then we have implemented deep learning. So biological neural network point of view, we understand the theory of the brain. So brain theory has motivated us to develop the artificial intelligence, because you have seen brain is a complex interconnected system of neurons in which living organisms are there, like human brain. Human brain, how it works, that process and transmit the stored information using electrochemical signals. So these networks, like we can see, the network consist of various components. That means if you see in the brain, various dendrites are there, or various cell bodies are there, or axons are there, or it will be characterized particularly by the plasticity and allowing the system to adapt, learn, and self-repair. That means if you see the structure of the human brain, it's linked by the synapse, and that is the concept of axon to dendrite, and one single neuron can connect to thousands of other neurons and forming the dense, that is very heavily dense, non-linear network. And here signaling would be there. That means the information will travel via electrical pulses are there, and that way is considered as a potential, and also chemical transmitter diffusion would be there. And particularly this way, that is the biological process will work, including perception would be there, thought, emotions, and with various motor coordination will involve. So as I said, plasticity and learning. So there is an artificial neural network, which we all say this, all this thing would not be there. Like static artificial point of view, it consists of recognize their structure and what are the strength will be there based on the experience. So component, that means this complete network comprise of network in terms of neurons with the various component would be there. That is the main unit of. So biological neural network serve as the foundations of artificial neural network. So artificial neural network, which is AI, which we are learning, that means we are developing the artificial neural network with respect to a layer-based system. And also when we'll see the control system, that means control theory. Control theory is very important part in AI. That means in AI, if you'll see the particular concept of the feedback system, we have seen in the particularly in a reinforcement learning. So reinforcement learning, which we have given the agent and the component. So control theory is a completely mathematical framework. That means we design the intelligent adaptive system which regulate their behavior to achieve the specific goal. That means we have data, we have controller, we have model, and how we are going to go to second state to third, then return back to second or return back to first stage. That is the theory of control system would be there. So specific goal, there is we are bridging the gap between autonomous system that is related to AI and agent will be there, that is controlling system. So when we are enabling the AI, that means to analyze the system dynamics, maintain the stability, and optimize the performance in real time. So real time with the less latency, minimum time would be there. So forming the foundation of robotics, autonomous vehicles, or many other points like reinforcement learning algorithm we had. So feedback loop, which is we have seen in reinforcement. AI system monitor the output like a example of speed as compared to desired set point. So we are adjusting input and managing the error, minimizing the error, and then again changing the error. So likewise, if you are maintaining the speed, you are going back, changing the input, getting the output. Likewise, this way we are reducing the error. So unlike static model, this approach will handle only the system can change over the time, like robot movement or chemical process. And stability and robustness is very important. Optimization is very important. So we'll see the autonomous system like self-driving car and drones, we are using control theory for navigations, for obstacle avoidance, obstacle detections, and path tracking. In a machine learning also, which we are optimizing, when we are training the neural network, that can be viewed as a control problem. So control theory problem, that means we are network weights are identifying. So by going back and changing the weights, by going back, changing the weight and reducing the error. So in terms of robotics also, we are controlling the movement of kinematics. We are controlling the trajectory planning, such as enabling the robot to the right path, run into right path, and manipulating the objects. So when we'll see traditionally AI, what you are using, and control theory we are using. So while traditional AI focus only pattern recognition or classification. So pattern will be recognized, classified, but control theory basically focus on trial and error. That means actions as well as your interaction within the environment would be. So all these are the major important component which can be analyzed. So when we see that pattern recognition classification was done at the time of normal traditional AI, but control theory will focus action and what is the interaction with the environment would be there. As we have seen, agent environment would modern AI, which combine both. That means machine learning, learn the model of the environment, and control theory compute the optimal actions. In that case, we have seen in reinforcement. So these are the main point which we observe for the foundation of AI. Now we'll see the application of the AI, like virtual assistant, various virtual assistant which are available, like Siri, Alexa, Google Assistant, which is the foundation of AI, which developed by the AI, use of AI to understand and respond with respect to voice command. So whatever the voice command will be given to particular device will react and provide the result. So this is the example which we are using in Google, which we are using in a system. As per the another application like recommendation system, which we are using in various recommendation systems are available like Netflix, Amazon, Uber, Booking.com. So that platform are using all this personalized content and product based on user preferences also. So they can recommend which like you are watching certain movies which is available on the screen, it's continuously coming. So they are using AI and suggesting to the customer or users with respect to personalized content and product based on the user preferences only. So they are giving ratings also based on that rating, they are able to produce the result only. So autonomous vehicle, we can see the driver is not available. So self-driving car which use the AI to perceive their environment, to navigate the road, to understand the road and object, and that network will be required to detect the distance between the vehicle and what is the speed. So all this will be carried out. All decision will be carried out in a real time manner. So that is the applications which we can see. Healthcare diagnostics. So AI system, which is very helpful and assist in the medical imaging analysis. Let's example in X-ray imaging. So X-ray imaging will see when X-ray of the chest will be taken to recognize the particular like conditions of the various pulmonary diseases. Like during COVID, we have seen. So like whatever the pneumonia condition would be there, that would be identified, as well as what is the tuberculosis identification. MRI of the brain to identify various diseases like Alzheimer or Parkinson or many other disease which is available and should be recognized in early stage for faster and more accurate diagnosis. So this is the AI system will assist, will provide the medical imaging analysis. That for faster and more accurate diagnosis. That means if you see the how the system will be able to accurately diagnose all these things. So healthcare is one of the area where we can say telemedicine system. That means healthcare diagnosis with just simple which we are going to apply to recognize the particular disease. That means what is the disease would be there in particular in a, but using artificial intelligence, how this kind of information will be predicted in early stage. That means in early stages, if you see how this MRI images will be utilized, how CT scan images will be utilized, how MRI images will be utilized, so magnetic resonance images. So AI will be very helpful in diagnosis point of view, because we are using machine learning, we are using deep learning or generative AI to analyze the complex medical data which is available in images, which is available in records, or many more, for faster and more accurate disease detection. And also it will add to clinical people. Clinician people are there in the area of like a radiologist, which is recognize the cancer, non-cancerous. Cardiologist will recognize the heart disease, or predicting the various future illness also. That means often supporting rather than replacing the human judgment. So human judgment will be the last to improve the efficiency and personalized care. So medical imaging, we're analyzing the X-ray, computer tomography, MRI, ultrasound, many more modalities are available. So that will recognize to identify the tumors, fractures, early cancer signs there that human might miss somewhere. Predictive analysis. So we have to identify the patients at high risk, whether the condition like chronic diseases are there, like diabetic or various other earlier situation. So, and also we can get the symptoms also based on the symptom checking. So AI tools which are very helpful for differentiate diagnosis from patients reported symptoms, helping the providers. So these are the major important area where diagnostic health diagnostic will improve using by AI. So machine learning, deep learning, all computer vision would be connected. So that means we can say medical imaging, predictive analytics, symptom checking, or many more like genomics or biomarkers. Like in that, AI powered tools will help in finding the patterns in a particular genetic data or in a particular blood. So to understand whatever disease risk will be there, treatment response by the drug will be coming. All these will be analyzed like smart home system. So AI-enabled devices will learn user behavior, how user are using particular. So like that, all these systems are automatically can be manageable. So adjust their setting to improve the energy efficiency, to provide the security, and to provide the convenient situations of the user. So same directions we'll see here, like in cyber security. So AI algorithm, as we know that we are under the threat of the cyber security, always there are many cyber crimes are happening. So we are getting like many calls. In that calls, automatically there is a, if the spam is coming, that means we can understand there is a automated secure detection, encryption, decryption. All these are the concept will be provided. So AI algorithm automatically will detect and respond to particular cyber threat in real time would be there. Enhance the network security, improve the data protection also, as we are using computers, mobiles, banking, and many more softwares, UPI, and many things. As we know that that's the reason we are under the threat of cyber. So cyber security, that means internally there is a self mechanism would be there, that how AI algorithm will detect that call is genuine call or that call is spam call. So would be recommended all these kind of things. Cyber threat can be track the particular system in a real time, enhance the network security and data protection. So similar way we can say the video surveillance system. As you know that video surveillance system is available in various places. Let's see the example of airport or like railway stations, bus stations, or many more in a malls, shopping malls, various places. So AI-based video system that analyze the video feeds, also detects the anomalies, recognize the faces, recognize and provide the secure monitoring. Let's see the example of surveillance system would be connected to the like a traffic surveillance. So in terms of intelligent transport system, the various on the road, various surveillance camera has been installed, and they can identify the vehicle speed. They can identify if they are violating the rules of the speed, or not wearing the particular helmets or belt or many things. So they can save the life of the people if sudden situation may come, like immediate action need to be provided during accident or many things. So all these video surveillance in terms of traffic monitoring system or toll based systems, you will observe. So how it will save the time and it will rescue the life of the people. So that is the important AI based system that analyze the video feed, detect the anomalies and all these things. Predictive maintenance. So AI models will analyze the data from sensors. So various data will be collected from sensor, predict the various equipment has failed or schedule the maintenance before their breakdown occurs. So we can say sensor installation on machines or connections to IoT platform, real-time data streams via sensors, or after that data monitoring. That means make sure that my machines are in the healthy condition. So connected machines, remote monitoring, then predictive analysis would be carried out by AI. Then proactive alerts will be provided future to maintenance need, or machine learning based algorithm using historical data to predict the failure. And then automated maintenance generation would be there for production scheduling, maintenance task scheduling, or technician assignments. Operator only has to approve the tickets on. All this way, this is the predictive maintenance task would be carried. So AI model analyze the all sensitive data to predict the maintenance or equipment failure and schedule the maintenance before the breakdowns occur. So supply chain optimization. So AI will optimize the logistic inventory management to streamline operations and reduce the cost in real time. You may get it like various logistic inventory managements are there where the particular procurement is there, asset management would be required, supply chain enterprise applications are required, or product life cycle managements are logistic. All this kind of thing will be managed by AI. So AI will optimize all these supply chain optimizations and reduce the cost in real time. Like gaming point of view, AI will enhance the gaming experience by the intelligent components, opponents, or dynamic environments, or personalized gameplay. All this way it will be helpful. Like we'll see the smart agriculture. So AI powered sensors, drones will monitor the crops. They will provide the automated disease predictions by the leaf images or monitoring of the particular and provide the solutions through the app. To the app will be given to the farmers. They can manage the particular fertilizations or whatever the recommendation would be given to the farmer, how much pesticide will be utilized, and soil condition need to be controlled. Weather will be predicted based on the precision farming would be carried out. So this will given for smart agriculture, smart healthcare, smart agriculture, smart automation system, energy grid management. So you can see AI will control the all strategy. That means from the various energy resources which is applicable, which is energy will be collected from the power stations, solar. So renewable, non-renewable energy resources are available, will be available for smart subway, commercial, industrial, smart home, smart vehicles. So AI will optimize the energy production, distributions, consumptions to maintain the stability and efficiency in power grids will be. So HR and recruitment, that is for industrial point of view, AI tool automatically candidate screening, assess the jobs fit will be there or not for that, enhance the recruitment process for business. So we are using various AI tool for different stages. Strategies will be provided for recruitment process, candidate sourcing, right job descriptions, recruiter chatbots, or resume screening, candidate pro screening, candidate evaluations, video interview analytics, candidate experience. All this would be carried out through the AI itself. Now, education and personalized learning. So people can utilize platform like deliver adaptive learning experience or assess student progress or provide the personalized feedback. That is also would be helpful in educational and personalizer. So when we want to development point of view AI languages, so programming languages are used in AI mainly. There is a Python is very popular, R or Lisp, Java, C++, Julia, Prolog. All these are the particular languages, and some of the languages are open source. People are using like Python and all. So it is Python is most powerful and easy programming language. That is anyone can start to learn
Python is initially developed in the early 19. Most of the developers or programmers, they are using Python, their favorite programming language, because of development of AI solutions. It's a worldwide popular language for developer and expert because it has more career opportunities as compared to other programming languages. R is also one more great language for statistical processing in programming. However, R supports for free open source programming for data analytics. And it may not be a perfect language for AI, but it provides the great performance while dealing with the large number. Similarly, we have Lisp. It's around for the very long time. It has been widely used for scientific research and originally created as a practical mathematical notation for program, but eventually it's become a top choice of developer in the field of AI. Java also one of the most widely used language as all developer programmer develop the machine learning solution and enterprise development. C++ also has been present for so long around, so it provides better handling for AI model while developing. Julia is one of the newer language which least was created for focus on performance computing. It includes several features like directly apply for AI programming. Prolog also one of the oldest language. After AI is developer need to define the rules, facts, and end goal. So programming AI using Prolog is different. It has several advantage and disadvantages are there. So as we know that currently what we are developing in AI perspective, like we'll see the generative AI model like ChatGPT and all can be generate the human text, images, or that is synthetic level. So even like the content creation and creative industry. So from creating art, creating codes, producing realistic deepfake videos, generative AI is opening up new possibilities and ethical challenges. Same multimodal AI, the type of AI that can understand, work with the different kind of information, same time, such as text, image, sound. Similar how human use multiple senses. So when you watch a movie, you process the visual senses, listen to dialogue, background music, understand the storyline. All these are the different sources. So multimodal AI aim to achieve similar capability to the machine also, allowing them to combine, make the sense of different types of data simultaneously. So agentic AI also makes sense in significant shift from reactive to proactive AI, and in science and healthcare and regulation and ethics. So regulation and ethics also very important because trend of mitigations, any risk associated with AI is paramount. So government agencies, the organizations like OpenAI ensure the AI is used for development responsible for ethically. So in March 2024, European Union debated a landmark for comprehensive AI will designed to regulate the AI, address the concern of consumers. So it's expected to become law. So if AI is not regulated, data manipulation, misinformation, bias, privacy can arise and it poses greater social risk. For example, tools can be suspected for discriminations or legal risk in AI does not collect data representative for a population. So generation like ChatGPT pull information from internet searches worldwide. So, but companies and publications have open AI for copyright infringement. So these are the trends are there. So thank you everyone. Any queries from the participants? Yes, any query, any questions? Okay, if there is no query.
Okay, sir. Thank you, sir.
If you have any query, you can mail me also. I will share my mail ID also. Yes, sir.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you. Thank you very much.
So we'll take a short break and we'll start the next session after 10 minutes. So good evening, everyone. I welcome all of you to the fourth session. So this session will be handled by Dr. Rasmiranjan Rao sir. So before sir start the session, let me introduce Professor. Professor Rasmiranjan Rao sir is working as a professor in the Department of CSE at NIT Telangana. He received PhD degree from IIT Kharagpur, MTech degree from MNIT Allahabad. He received many awards from the reputed organization, including IEEE senior member. He has published more than 50 research papers in various reputed journals and conferences, including IEEE Sensor Journal, IEEE Transaction on Computational Social Systems, IEEE Transaction on Wireless Communication, Computer Communication Elsevier, Vehicular Communications Elsevier, Applied Intelligence, Pervasive and Mobile Computing, Journal of Computer Networks and Communication, Computer Electrical Engineering Elsevier, and IET Wireless Sensor System. He is a member of ACM, life member of IST and others. His current research includes Internet of Things, wireless ad hoc and sensor network, online social network, cloud computing and mobile computing. He delivered many talks and chaired sessions in many national and international conferences. He acted as a reviewer in many reputed journals of IEEE, Elsevier, Springer, and many reputed conferences. He completed a project titled Design and Development of Multimodal Geosensor Network for Ambulance and Noise Nuisance Monitoring in Urban India of worth 33.06 lakh from DST New Delhi. With this introduction, I request Rasmiranjan Rao sir to start the session.
Sir, sorry, sir. Good evening. Hello.
Yeah, madam.
Yeah, attendance for the attendance link not sent for the second session.
You please attend the session, madam. We'll see that this thing later.
Okay, sir. Okay. Because if you give the instructions, we won't disturb, sir, when we will get the attendance. Otherwise, we are posting, keep on posting, because we know that every session.
Attend, madam. We'll see this thing at the end of the session.
Okay, sir.
Am I audible? Hello?
Yes, sir. You are audible, sir.
Voice is clear?
Yes, sir. Yes, sir.
Got the slides. What about my slides?
Yes, sir. It is visible, sir.
Yeah, good evening, all the participants. I thank coordinator for introducing me, and we'll discuss my title of this talk or this presentation is AIML for UG and PG curricula. So, what type of courses we can include for BTech students, for MTech students? So that we'll be discussing, and specifically what type of courses we have here at NIT Warangal for our department, for computer science and engineering. So that I'll basically highlight, and the importance of such courses that we'll be discussing, and what is the future of these courses and why these courses are required and for several courses how AI and ML is an integral part that we'll discuss in this session. So AI and ML for undergraduate and postgraduate curricula. So for UG curriculum, PG curriculum, what type of courses we should include, what type of courses students should study, so that those things will be discussing. So before going to those courses, I would like to spend some time on AI for education. So how AI will help, different type of AI models help us in teaching and research, and different type of courses that will help our students, especially BTech students, fulfilling the industrial requirement. Similarly, different type of AI models, AI and ML models for master students, and based on, so that the students can solve industrial and societal problems. And of course, AI is future. AI is important when we consider future research directions. This is not limited, AI is not limited to only to computer science and engineering. AI can be used for several disciplines: civil engineering, mechanical engineering, electrical engineering, in various applications. AI can be used in smart grid application, in electrical engineering. Similarly, AI can be used in cellular networks. AI can be used analyzing IoT data. So many more applications. AI can be used for AI can be used in autonomous vehicles. So several applications we see where AI and ML models can be used. And of course, our student must study those courses in their UG and PG. So let us spend some time as a teacher, as a student, or you can say in classroom teaching, beyond classroom teaching, both online teaching and offline teaching, how AI can be used. Of course, when I say offline teaching, some of the tools can be used. Different type of content can be generated for offline teaching, but primarily, so when we are discussing about AI, so whether it is offline teaching or online teaching, whichever the case may be, but how AI helps in teaching and research. Let us spend some time on that. So AI helps automate grading and feedback, so that different type of models can be used for automate grading. So when we say that automate grading, generally what we do manual grading, right? We evaluate different questions and we award marks to the students, and then we give the key. Based on the key, we evaluate and we decide the grading. But if we think beyond it, that based on several parameters, based on the response in the class, a student, how is he responding in the class? how many such questions in class itself a student has responded. Each student, how he or she responds in the class. That data, whether it is, we can take it for grading. So these are challenges. That means how the student is listening in the class, how he is responding, how frequent, whether he is attending, when he is listening the lectures. So really he is listening, how much he is listening, he is attentive or not. So, and to understand that whether a student is learning the technology, how much he is learning the technology. Not only asking questions in the examination, in addition to that, several other skills can be considered. And or we can also consider the submission of assignment patterns. We give assignments to the students. Some of the students may copy the assignments. Also, some of the tools will help us to find out how many assignments are copied. That also will help us to evaluate. Right? So for automatic grading, we can do, if we use a different type of AI and ML models or appropriate AI ML models. So it may help us grading the students, awarding different grades, not only through conventional classroom testing or conducting exam and awarding marks manually, but we can do beyond that. So we can consider this is one of the future perspective where AI models can be used for automate grading and feedback generation. Feedback also can be periodical feedback, can be collected from the students, and similarly can be collected from the teachers as well for various aspects. So AI can be used for tutoring and explanation. So to explain a concept pictorially, different ways a content can be explained. A content can be explained with by using several pictures, right? Several images. Tool can generate several case studies can be considered with both text as well as images, videos, so that students can understand in a better way. So this will help. So what we understand that basically what if we design AI and ML models for tutoring and explanation, this will help teachers and to basically to explain some of the questions and their answers and different type of possible answers with different type of examples. A teacher can use different kind of AI models to generate those. And one of the currently we are using different type of LLMs. So for this purpose, hopefully in this workshop, other speakers will be discussing in detail about different type of LLM models. So I'll not go to those things. So these models also can help us in curricular development. So when we are developing our curriculum, suppose we are developing a BTech curriculum, so we want to know when we are designing a new one, suppose you want to offer a course AI, artificial intelligence, BTech in AI, or you want to offer a course BTech in smart grid. So there we must find out what type of curriculum exists in other universities it is very difficult to find out manually. So different type of AI tools can be used to gather such information, as well as not only that your name of the subject, but the content and syllabus can be generated course-wise. And also we can refer authentic sites to find out that whether such such syllabus or course exist and proper textbooks are there or not for those curriculum. So when we're designing a curriculum itself, different type of AI and ML models can be used. So we can analyze student performance in as I told, periodically, and also different type of alerts can be generated if a student's performance is basically in a downward direction or in a upward direction. Appropriately your suggestions and your supervisor or advisor or teacher can give different suggestions for further improvement to the student. So student performance can be analyzed using different type of AI and ML models. So some of you may be, most of you may be knowing that what is LMS, Learning Management System. Different type of LMS like Moodle LMS, Google LMS. There are different type of LMS, learning management systems exist, which provide an interface for the faculty and students. They can share content with each other. Assignments can be graded through the LMS for the students. Student can write online tests through LMS using Moodle. Several such tests can be conducted. Several assignments can be posted. Lecture materials can be shared through LMS. So, and these Moodle LMS, Google Classrooms, these things are, these LMS tools are used by various teachers and students for improved teaching and learning. Now, how AI plays a role in that LMS? Right? So, AI and ML models can be integrated with LMS, analyze the LMS data. When I'm saying LMS data, so that is student performance over a period of time. So suppose say a student performance in the first year, student performance in the second semester, student performance in the third semester. Semester-wise, student performance can be monitored through LMS, and those can be analyzed through different type of AI and ML models, right? And different type of patterns can be found out. And just when we are analyzing this, you may be hearing nowadays different type of online degrees. Different universities they provide different type of online courses like Coursera, or different type of online your materials are being shared. So the number of students who the number of students they register into such LMS tool is basically, if you see the scale is very high, right? That large number of students they register in online courses, and for which are being offered by various reputed institutes, right? So they want to know their pattern. They want to use different type of AI and ML models to analyze those LMS data for thousands of students. And when I'm saying their data, means question wise, which type of questions, even if personalized learning, that which type of your courses are good for the industry. All those data also we can consider, right? So, which type of questions are very tough for the students to analyze, basically to attempt, so that those patterns can be found out. So, if we can also predict if such type of questions comes in an examination which you will be conducting, so what would be the average mark of the students that can be predicted? So, question wise it can be predicted, subject wise it can be predicted. So many things can be done when we integrate this AI with LMS. And this AI can be used for personalized your learning. That also we can consider not only when this curricula we are designing or developing curricula for UG and PG students, we should also take the input from the industry and what type of courses, what type of skills are very much required for the industry, so that that will basically create more and more job opportunities for the students. So those factors, in addition to that industrial factors, we have to also consider the economic factors, like that in which sector there will be funding, right? Which sectors job openings will be there. So all those things also, basically your economic condition of a country also plays a role in placement as well as your personalized learning. That means which type of learning a student should do based on their interest, and so that they will be placed in good organizations and good company. So beyond thinking beyond our manual kind of you are deciding the curricula and using only experts' knowledge. So we can think, we can use different type of course, we should involve your curricula preparation. Of course, we should involve professors, we should involve industry professionals, we should involve other experts in those domains with the skill sets. So in addition to that, we can use several such tools which provides us enough your in detail information about such curricula that exist in other part of the world, as well as we can also predict what would be the chances of placement, what would be the future aspects of these courses if students study, whether they will be placed in good companies or they can go for higher study, and so and so. So similarly, we can see the AI has a great role to play in next generation technologies. So when I say the next generation of technology where the AI basically will help us, one of the technology which is industry is currently interested is on industrial IoT, Internet of Things. Industrial Internet of Things, IoT, or only Internet of Things, IoT. Similarly, as I told you, smart grid, autonomous vehicles, smart, we can say that your monitoring and analyzing different type of activities based on different type of parameters in a chemical plant, right? Similarly, we can do analysis on different type of diseases, or we can say in biotechnology. AI has a great role to play, and in the biotechnology domain, in chemical engineering domain, in materials. So several your applications we see are we need AI and ML models to provide solutions in different domain. You can say that other engineering domain, they want to solve their problems using different type of AI and ML models. When I say other engineering domain, other than CS, computer science, I mean other than computer science. So there are several technologies and where we require AI and ML models. Of course, in defense, that is another aspect. In defense, we require several such technologies to analyze, to identify, and also another is security. Right. So when I say security, it may be cyber security, it may be any other type of network security where AI provides security. Similarly, there is another your aspect. Sometimes there may be attack on the AI model itself. So then you require a security model to basically to detect whether your AI model itself, the learning model itself, is basically being attacked by an attacker. Right. So AI for security and security in AI, these both things also you can look into when you see that next generation technologies, AI for next generation technologies, such as IoT, smart grid, autonomous vehicle, high-speed trains, bullet trains. A lot of things can be done through AI. AI in healthcare. AI in healthcare. Any question? Am I audible? Can someone please respond?
Yes, sir.
Sir, yes, sir.
Okay. Thank you so much. So let us.
Good evening, sir. This is Abhishek.
Yeah.
Sir, I just have a question related to like evaluation for students. Just because we are using AI models, sometimes it happens that it gives false positive or false negative results.
True.
So, how to be very vigilant about those if we are planning to have these AI models to be used for student performance evaluation, sir?
Yeah, true. So basically, what you are saying is true. Most of the models, when you use, there will be always you may not get 100% accuracy, right? So that's what the teacher. When I am saying that, this will help the teachers, right? And when you are analyzing that, you will get. Suppose I say we are generating different type of images to explain a concept, right? So in that case, you can choose. If you think that one is not relevant, I'm saying only teaching purpose. Let us assume very simple way. If one image is not much relevant, you think that, right? That will be removed. So you have to see highly, basically, as much as you train the models, right? And with your unbiased data, okay. So your model will get, you can say that model will predict with more accuracy. Okay. So those challenges are there. Therefore, several researchers, if you see, they try to improve these overall accuracy of the system with various kind of parameters they take. They try to improve it. So those challenges will be always there because we are predicting based on the past data. So I'll just go through those algorithms also, which type of algorithm we can do what, right? So where we can apply, which type of machine learning algorithm we can apply in which type of applications. Just I'll give a overview of that. So you can choose whichever applicable where, but what you are saying, it's fine. So we should be very much careful when you are using the model, right? Few cases it may give some data which may not be relevant.
Sure, sir. Understood. Thank you.
So there are various. I'll just have some awareness about this. You may be, most of you may be using those these models, LLMs, ChatGPT, Gemini. So several LLM models now people are using to generate different type of content, and of course they get the source of the content from which the content is generated from, based on which internet sources, those also that will show. So, but it is helping. Suppose you want to summarize a concept in with an image or with a certain text of 50 words or certain text of 100 words, certain the same concept in 1000 words. These type of tools are nowadays helping to basically explain a concept, and that helps the teacher when they are doing it. Then when they are using for their preparing some kind of notes and all, right? Although they know the concepts, so that helps them. So several LLMs people use to explain the concept, create summaries. You can use practice problems and lesson plans, how to prepare, what type of topics, subtopics will be there. For a particular course that you can find out with relevant references. Also, you can find out from which source is more relevant for that particular content. That also you can find out. And also, it is very interesting to give different type of use cases for our students. Right, when we are teaching a course, several examples. When you basically refer a book, there are several exercise examples, right? So then what we do generally, we take some questions from the book, and then we give to the students from the exercise problems. Then students practice them and all, right? So several challenging use cases you can generate, right? So it is you can customize them, you can modify those challenging problems, you can make it more challenging, you can add more case studies into that, you can change several parameters into that, and so then you can create a good assignment for your students, right? Similarly, for the student side, right, they can study the concept from a book, and they can work out some of the examples exercise. If you are not going, a question you can find out, right? Similar questions, different ways the question can be formed. Those also can be practiced by the students. So models, this type of AI and ML models, customize learning paths in real time based on student response, track strengths and weakness. So basically for adaptive learning, so as I basically discussed earlier, that we can track student performance over a period of time, and also based on different level of questions, we can also predict what would be the our maximum mark, what would be the average mark, if such questions we give to the students, or any kind of test we want to conduct based on the past experiences. And of course, challenging exercises can be posed in front of the students to solve. Several type of videos, reading materials can be created, and also it can suggest, suppose there are different type of concepts, difficult concepts. So what type of other concepts we should study so that we can solve such problems. So suggest some next topic, what we should study, which topics are basically linked to this current topic, and to solve a particular problem, what concepts students should study. So those kind of things also it generates based on the data. So when we are discussing, so far we we spent some time on AI and ML models, and what our students should do, and how these models basically help in teaching and learning. We spent some time on that. Okay. Now let us see that what type of algorithms we have. Specifically, let us focus on only on machine learning algorithms. Some of the machine learning algorithms here, and where we can use those algorithms in different cases. So then actual use cases and all you can always find out from that, right? So let us spend some time on this. Then what we do basically, although some in some other sessions you will be listening similar topic, machine learning, AI models, different type of machine learning algorithms, AI models and all. So let me little bit revisit and see what type of applications or on what type of problems we can solve using machine learning. So what do we do in machine learning? So it is a field of computer science that uses techniques, algorithms to give computer systems the ability to learn. Right. So that is, it gives the computer an ability to learn. That means earlier computers were not learning. Computer was a machine. Generally we think what? Computer is a machine. When we say yes, computer is a smart computer, that means we want to introduce some intelligence into the system, or we want to design some algorithm so that machine should be smarter. That means it should take some decisions, right? So we are giving the machine the capability of learning. How? Through learning algorithms. So another term I have introduced. Only I named it in my first slide, that is Internet of Things. So what is this Internet of Things? To understand the simple way, you might have heard already Internet of Things. So several smart objects embedded with sensors. Let us say this is a smart object. It is embedded with a sensor. Suppose, what is a smart object? I say this is a vehicle. This is an autonomous vehicle. And it is a smart object. Then this autonomous vehicle must be integrated with several sensors to generate data. Right? Several sensors are used in the autonomous vehicle to generate data. Data related to what? If this vehicle is moving on the road, right? Then there may be cameras which will be taking different images of the road and also around the vehicle. Similarly, different type of object detectors may be there. And in addition to the traditional sensors for the vehicle, monitoring the speed of the vehicle and whether the engine is functioning well or not, several sensors they integrate inside the engine to basically to monitor whether the engine is functioning well or not. So if you consider this is a smart object, and this smart object has sensors, and these vehicles, let us say this is a roadside unit or a base station where this vehicle is connected. That means it communicates through a roadside unit, and this roadside unit connects to let us say through the cloud or through the internet. It connects to the internet, and this vehicle can upload its data to some remote server through the internet, through the roadside unit, and also it can access the road information ahead of it through this connection. Now, what is IoT? IoT is the full form is Internet of Things. That things are nothing but objects. Objects are connected. They can communicate. They can sense. They can compute. Right? And that you can say tiny computers. Suppose smartwatch. right? That you can consider the smartwatch as a your IoT object, right? So, and also these autonomous vehicles, you can consider them IoT objects, right? Drones, you can consider them as IoT objects. A drone must have some sensors. It should sense the data and it must communicate with a nearby gateway and through wireless. And then this data must be, the data must be accessible through the internet, right? So that drone data can be analyzed, right? Drones can be used in agriculture. Drone can be used for monitoring flood. Drone can be used for monitoring movement of human mobility where there is a large gathering and all. So several applications you see, you find out. Drones can be used in the war, right? Different countries, they use the drones in the war. Right? So drones, these are smart objects, right? Now these IoT devices, right? If you give some intelligence, then machine learning gives IoT device and machines a brain to think, which is called embedded intelligence. Machine learning algorithm can make predictions, see what actually happens, compare against its predictions, then adjust to become more accurate. So that means different type of algorithms you can use to predict different type of event for which these IoT devices are implemented or are deployed. So a model of learning is fundamental in any machine learning application. So what we are interested when we want to know why machine learning, right? And in machine learning also, if you are implementing machine learning algorithm in a smart object, so then you have to answer these questions. Who is learning? In machine learning, who is learning? In very simple way, you have to understand who is learning. A computer program is learning. Right? What is learned? A domain is learned. What is the domain? Healthcare. Healthcare is the domain. From what the learner is learning, the information source. So then if you are applying machine learning and machine learning models, then what you require? You require data. Data related to what? Related to a domain. So if you require, if you need healthcare data, so that this data can be analyzed, right? This data based on the past data, the machine can learn, or your program can learn, and you can implement that program in a smart device, and then it can predict based on your learning pattern, right? Simple way if you want to understand that. So if you want to work with machine learning, given a machine learning problem, what you have to do? Where to start? Right? So you have several your different type of machine learning algorithms are there, right? So what do you have to do? Where to start? How to implement? How to test? How to apply a machine learning into a real world societal problem? First, identify and create appropriate data set. If you are using a supervised learning, you require a level data set, right? From where the model learns. So now you require one appropriate data set. Then perform computation to learn required rules, patterns, right, in the input. Or input means the data set. What type of patterns are there? Right? Then finally, the machine learning should give us output decisions, right? When you try to take a decision based on various you want to predict something, then it should give a decision. So predictive capabilities are extremely useful in an industrial setting. By drawing data from multiple sensors, in our machines, machine learning algorithms can learn what typically of the machine learning, then detect when something went normal. So it is various, this is true for various applications, not only education, for various industrial problems also, machine learning can be used, right? So in our curriculum, when we are designing, definitely if we see that machine learning can be used or to solve different type of industrial problems, right? It can monitor the health of a machine, health of a mechanical machine. Then there should be some course which will be offered to the mechanical engineering department, right? One IoT course integrated with the machine learning for their machine should be taught, right? So that means based on the requirement, based on the need, so curriculum can be designed. So several case studies can be formulated based on machine learning. One more case study is the collected data is sent to a server where it is compared with previous data collected from the machine as well as data collected from similar machines. The platform can detect and if there is a change and warn you of developing malfunctioning. Suppose you want to monitor a machine, as I told you, if the machine is malfunctioning, right, then the machine learning algorithm, what you model, what you deployed, must warn it, right? So this analysis is done in a real time and results are displayed on the technician's smartphone. That now this data also should be available through smartphone. So this is basically, you can say, you require integration of IoT, machine learning, right? Both you want to apply on different type of physical systems, right? Like a mechanical machine must be monitored in real time, right? So you require IoT, you require machine learning, and so on and so on. So to understand few more things on machine learning, and when we give examples to our students, right, that how machine learning will help and in which way we help. So several examples we can give, right? Machine learning is valuable for accurately predicting future events. Now let us understand such type of questions can be posed in different contexts also. Let me ask few questions, right? And then you will realize, yes, there is a need of machine learning for such complex system. Which road is going to be congested? If you want to answer that there are several roads, consider the road network, right, in the country, right? Several roads are there. Which road will be more congested in future? Future means after 2 hours, after 3 hours. So this type of data we need, right, when vehicles move on the road. Which machine is going to be down, right? Then I'm saying that you are applying machine learning in for a IoT machine learning for a machine, right? A mechanical machine or a electrical motor, right? You want to know which your component or which machine will be down after some time. Condition of a patient in healthcare. So this is for a healthcare application. So we want to know, we want to predict the condition of the patient in healthcare. Then for that, what we require? Again, we require IoT data. We require machine learning, right? Models to analyze this data and will determine how the parameters, real-time parameters of the patient, such as your heartbeat, right, and the other parameters based on the type of sensors what are integrated into a patient, right? Not only we are observing or monitoring the heartbeat, several other parameters also can be monitored by designing different type of IoT, healthcare IoT devices to measure patient's health. basically to monitor patient's health, right? We have to analyze those healthcare data, right? Not only that, these patients earlier past data, so that some kind of X-ray you have taken. Suppose somebody is having knee injury, right? Somebody cannot walk properly, so there are artificial. Some people use healthcare artificial devices, right? Whether the device is not functioning well, so that also can be monitored through sensors, right? Which applications are eating more resources in a smartphone? This will be answered. Which portion of the city will be more polluted? Again, you require pollution applications. You require AI and ML models to determine whether a city is polluted or not. Okay. Which portion of the country will get less rain? Again, depending on the previous data, we have to predict. Which portion of the city will be consuming more electricity? Depending on the infrastructure growth over a period of time, we can predict. Which type of diseases spread faster, are currently spreading faster? So that can be determined, right? So you can find out several societal applications as well, not only education, several societal applications where machine learning and AI models can be used, right? Now, let us see the groups of algorithms which are available with us. Supervised learning, where these algorithms learn from level data, where we know the outcome, right? It's available in the data set. Then you can apply supervised learning, and the learning models can predict. And similarly, unsupervised learning are the other categories. Another category is unsupervised learning, where there is no level data. The outcome is not known in the input you do not have. Then we can use grouping of this data. This type of algorithms used for anomaly detection kind of thing. Also, we can group different type of, to determine different type of patterns, like which type of products are sold more, which type of users are purchasing certain items. We can, different type of parameters we can take, and then we can group them based on similarity, right? So there, and because there is no level data, we can apply unsupervised learning there. This another category is reinforcement learning, which learns through trial and error methods, like a child learns how to walk, right? Initially, a newborn baby cannot walk, right? But it slowly learns how to walk, right? It generally, the baby uses trial and error method, and also, although it will be basically will be monitoring the other objects nearby, how the other objects will be behaving, how they are doing based on that. But so many things, learning happens through trial and error methods. There are different type of models are there. Under supervised, I am not going through detail into the models. Supervised learning category, logistic regression, your KNN under supervised, decision tree, random forest. I think some of the, in some other sessions, your speakers will go into detail of some of the algorithms, so I am not going to that. Unsupervised learning, K-means algorithm, hierarchical clustering, DB-scan algorithms are there. And under reinforcement learning, what I told is basically these AI type of models. Here, this is a type of machine learning approach where an agent learns how to act in an environment by interacting with it and receiving rewards and penalties based on its actions, right? That comes under reinforcement learning. So Q learning is one of the algorithm, SARSA is another algorithm, deep Q networks is another reinforcement learning algorithms. So these things can be used in healthcare and all. So I am not going into detail. Some of the things we discussed about healthcare, and these are some of the applications. If time permits, we'll see. Now we'll see that what type of subjects and curricula the students are studying in BTech, Master, especially in UG, PG students. What type of subjects are there? We have a course in BTech Computer Science and Engineering that is called Artificial Intelligence and Data Science. Students study in 4th semester Artificial Intelligence. So in detail syllabus, everything available in the website, right? You can refer it from that. Any deviation, you can just compare it also. So 4th semester, they study Artificial Intelligence, which is a professional core subject. Then they study Machine Learning, another course, Data Science Fundamentals. They study in 5th semester. So this is 4th semester means the second year. These courses are offered. Your fundamentals of artificial intelligence, then machine learning models. Then 5th semester, they study data science fundamentals, data visualization techniques and design, that is covered in 5th semester, business intelligence covered in 5th semester. So these BTech AI and data science students, they study more, in addition to AI, they study more aspects of data science, data analytics, right, statistical methods also. So data visualization techniques and all, right? So business intelligence. Then 6th semester, the students, they study deep learning. Then there is another interesting course, natural language processing. That is also a 3-credit course. And in 6th semester, they have a deep learning lab. So that is a professional core. And this is a natural language processing also having a lab component. So for the detailed syllabus, I am not going to the detailed syllabus that is available in the website, or if any of the participants wants to know the detailed syllabus, we can provide, you can mail us, right? Formal verification of machine learning models. There is another, this is not core, this is elective, that is written, you can see that. Which type of course, right? How many credits, these are mentioned, credits are mentioned over here. Similarly, subcomputing techniques is offered in the 6th semester as well as an elective. And IoT data processing, as I told you, IoT is sensors, this part, right? We discussed a few things, so that is covered under IoT data processing, how to process IoT data, those things. This elective covers it, right? So these are the courses, although I mentioned some of the AI and ML courses, but there are other courses where some portion of the machine learning models are used, and some other portion or other components or some other modules that teach those specific your domain, right? So here I mentioned that mostly where more AI and ML components are there, that I have grouped. I am just showing you those courses which comes under artificial intelligence and data science, right? But in addition to that, we have, suppose, so we can teach social online social networks, social media analytics. Those courses also will be part of that. Sometimes we put it as an elective, and based on requirement we use it, right? But there are other courses also where AI and ML models are being used. So in the 7th semester, we can see that the computer vision and image processing, medical imaging, both are electives. Recommendation systems. So this course basically different type of models what are required for recommendations, right? So for the users, so those type of models are being taught here. And sequential decision systems, is another course. As I told you, social media analytics we teach as an elective. AI in robotics, right? So AI models can be used, or we can say it is an integral part of robotics now, right? In the robotics, when we are creating smart objects and we are controlling the object, our object also takes decision on its own, as well as those through IoT based technology, we can also send some your messages, or we can signals to the robot, and robots also can reply. So through IoT also it is possible, as well as the robots can take decisions based on inbuilt AI and ML models, right? So AI in robotics is another important course. Predator machine learning models. This is basically a distributed learning kind of thing, right? When we are saying that a model will be trained with some data and all, right? So in predator learning, what we do, basically data related to say location 1, data related to location 2, data related to location 3, and data related to location 4. Let us say it is a healthcare. So healthcare data from one hospital, healthcare data from another hospital, healthcare data from another hospital. So there is a local model can be deployed in one hospital data, on one hospital data, and the model can be trained, and model parameters can be sent to a global model. So, and there, this local model parameters can be sent here. Local model parameters can be sent here from this location, and local model parameters can be sent from this location to the global model, right? So then finally the global trend model takes all type of decisions. So it is basically, you can say it is a distributed learning kind of environment, that is predictive machine learning. This is widely used because our data are, we can say the societal data may be specific to specific region, and they may be related. When I'm saying hospital, the type of the hospital which we have, and we are collecting some data, let us say for a specific disease, if the similar disease is also basically monitored or analyzed in another country, the parameters, the demography may be different from one country to another country, even for the same disease also. This local model training may vary, right? So when you are learning, when you are training the local model, and then after the local model, model parameters can be shared with the global model, then finally the global model can be generated, right? So that is very interesting thing, solving various you can say recent problems, starting from healthcare, even if industrial problems, several industrial problems, right? This predictive learning solves them. Right? Another course is human computer interaction. So basically both machine and human should, we can say, you have to develop smartness in that, and how they can communicate with each other, or I can say with the different languages, right? Communication also may happen. So and different type of languages, when you are using different type of languages, one language converted to other language which will be understandable by human, and which can be understood by different type of applications deployed in the machine, and then you will have a synchronization among human and your machine. So large language models, LLMs, and different type of that some of the things we discussed earlier. So you must have a course if you are designing curricula for if you have faculty members you are attending, so you are designing curricula. So now large language models are being widely used, or you can say not only used, widely used in various purposes, right? And so that you must have a course on that, right? Next is reinforcement learning. Already some that I have introduced already. Reinforcement learning we should have, and it has many such your applications. Reinforcement learning has many applications in the real world to solve real world problems, right? And virtual VR and virtual reality and augmented reality. So this basically helps to study and to provide different type of solutions for various kind of components used in mechanical engineering, civil engineering. Suppose I say structure, or it can be used for mechanical machines. So where AR VR can help help a remote engineer to solve problems for a plant, right, or any other kind of application for which AR VR is generated, right, or deployed, right? So AR VRs also being now people are interested, or especially industrial applications are there. So therefore, you should include AR VR in your curriculum. So we have a course in BTech Computer Science and Engineering, in addition to BTech Artificial Intelligence and Data Science. So here also we have similar courses. Although we'll get more number of electives in AIDS electives in BTech AI and DS. Here in BTech Computer Science Engineering, we have we can say that more electives are there here in AI and DS. AI and ML electives, more courses are there as compared with BTech CSE. BTech CSE also we cover, we also teach all the core courses, AI, artificial intelligence of 3 credit, although it is there as a here. Some courses are core courses, some courses are elective courses. So that are being offered to the students. Machine learning laboratory is also there. Human computer interaction, advanced data mining. Students study different type of data mining techniques, how they people use that to solve different type of problems. Model driven frameworks, deep learning, natural language processing, computer vision, image processing, intelligent agents, how to design intelligent agents, what are the key components of intelligent agents. So those students also must study those courses, right? And also, of course, VR and AR are part of this BTech curriculum. So when we are basically teaching the BTech students, we have to also see the another aspect. These are the courses we are teaching, right? But they have to handle a project, right? So they have a minor project, right? They have to solve a societal, industrial and or societal problem as a part of their your BTech final year projects, right? So there is the students can apply AI and ML models to solve different type of the part of their project. They can use AI and ML model to solve different type of industrial and societal problems, right? So most of the universities, they have this project in their final year, and the students do develop different type of products or prototypes as a part of their project work. So these courses, what they study in their curricula, in their in BTech curriculum, so that will help them to carry out these your projects. So although when I'm saying projects, now the students are free to choose their societal problem, right? Here we ask the students, you can choose any societal problem or industrial problem or any other health problem from the agriculture or healthcare or finance. So they choose a problem and they choose the particular data set what they want to analyze, and based on the requirement, based on the type of data, based on the input they have, and based on the outcome what is expected from the project, they decide the machine learning models, what or which type of, whether they require reinforcement learning models. They decide, they do some research, and then they decide what type of model. They design different type of AI and ML model to solve this industrial or their basically project works, right? So that this in addition to these subjects, this AI and ML subjects as a part of BTech curricula, the students are supposed to execute projects, and primarily we see that most of the projects students use in AI and ML models and to solve problems. So when we are teaching these courses, also as we give assignments, right? As a teacher, you have to give assignments to the students, right? So when the students take those assignments, and then you have to evaluate those assignments through LMS you can give, and they will submit. You can find out that whether the student has how the student attempted it, subjective as well as objective kind of things, right? Both you can do that. And when you are giving assignments, and we find there are several applications, of course, related to the course which you are teaching. Suppose I am teaching social media analytics, so the Twitter data, Facebook data, right, that can be given, that can be used by the students to analyze, to determine various patterns, like detecting a rumor, right, detecting the source of the rumor, from where a rumor is being generated. So this type of study they should do to solve some assignments, to solve some projects, or basically to as a part of project work also they can carry out. So depending on that type of type of course, they can decide the type of data that they want to analyze as a part of the course, right? If data data changes, right? Yeah, you can say that some other courses can be included also. Not only these courses, we have the liberty as a curricula when we are designing here. So we can also propose new electives through our Senate, that we can request them. We want to, suppose you want to include a new elective, let us say AI in fintech. You want to introduce a new course, how AI is helping in providing your security in finance, security in insurance. So such course you want to introduce as an elective. So you should always open to include new electives in your elective pool, right? So that students, new batch of students, they should study new electives. That will help the students, and that will also fulfill the societal need, the industrial need, and so and so. Right? So another thing also I told you, AI for security. Those electives also can be floated. AI for security, right? So how you can use AI to provide security and privacy, or you can say AI for privacy, data privacy. AI for data privacy, right? AI for security, right? Which type of models we can use to provide security. Similarly, you can also offer courses where security in AI models. That means what are the AI models? When I'm using AI models in different domain or on different type of data, so that time whether the models are also challenged or vulnerable to attacks. So that part also can be studied, and then how to solve those problems where you have security problems in AI models itself. Similarly, we have a course MTech Computer Science and Engineering, where we a master level course. We do teach here some models for the benefit of our students. The code are different here. For PG code and your UG code are different, and we can teach additional machine learning, advanced machine learning models into PG courses, right? So you have when you are designing the syllabus and all, you can include new models, advanced models into the curricula when you are basically teaching the students. Not only when you are teaching the MTech students, as well as when you are teaching, especially the final year BTech students, basically they should also learn some advanced courses. So these courses, some of the advanced machine learning or deep learning courses with advanced models also can be taught as a part of final year BTech students. I mean, courses can be offered to final year BTech students, because that will basically fulfill the industrial requirements immediately, because first final year BTech students may join the companies immediately. So computer vision image processing we have here, advanced artificial intelligence is part of this. Deep learning models, deep learning lab is part of MTech computer science engineering. Interactive, exploratory interactive data analysis is part of the human computer interaction, social media analytics, reinforcement learning, NLP, so subcomputing techniques, advanced data mining are part of some of the courses which are part of the MTech courses. And these MTech students, they study 2 semesters, right? And after that, they have 1 year project, right? They have one year dissertation work, right? So they do that 1 year research, and what we observe, several domain they work, and they apply this AI and machine learning algorithms they do some research, they fine-tune models to solve various type of industrial and societal problems, right, using this. The knowledge whatever they gain from these courses, they use that to solve their research problem in the second year project work, right? Also, there are some of the courses, what can be considered is basically AI in software engineering. You can include as a elective course, AI in software engineering. Right. Several other courses can be included where AI and ML models we want to use to solve or to solve different problems, solve some problems in a specific domain. When I'm saying domain, is basically a software engineering is the best, is the actual course where we are going to study how AI will be helping software engineering your processes. So we have a MTech computer science and information security. Primarily focus here is design secure systems, network systems, network security. So here also we have in this course, in addition to security courses, we have AI and ML courses. So I'm not showing you the security courses in this slide, because you can go through the website or the entire curricula is present, because my focus here is just to show that the AI and ML courses. So those are I mentioned here. So as I told you, security can be added, security in AI models. Similarly, AI for security will be a part of AI for security, AI for data privacy. So these courses can be added as electives, right? As a part of this, always you have to revise your curricula based on industrial and societal needs, right? So new electives we should keep on adding based on our requirement. Like currently, quantum computing. Basically, people are interested to design quantum algorithms. Right? People work in quantum crypto, right? So those such courses also should come into your curricula. Although we are not discussing much on quantum today, but those new courses also can be included into the curriculum. Right. So here we have also data mining, data science fundamentals, computer vision, image processing, advanced artificial intelligence, big data analytics, your deep learning lab, human-computer interaction, social media analytics, NLP, subcomputing techniques, advanced data mining, reinforcement learning, right? And the students not only they solve, they design, develop systems, they also design secure systems, right? So therefore, these courses also can be part of this, right? When your focus is on AI and ML, so there in security courses also, this type of electives can be you can target with security in AI for security, AI for data privacy, right? And similarly, your AI for cyber security, or you can say digital forensic, right? Such courses will enhance the students. It will give the students the ability to analyze, to understand the systems, to analyze the systems in a better way. They can understand the system, they can design a secure system, as well as they can apply AI and ML models and for more accurate analysis, and that will fulfill both societal and industrial requirements. So that's it. Some of the references are here. Some of the content are taken from these references. Okay, thank you. And if you have any query, you may please ask. The detailed syllabus and curricula are available in the website, in our institute website. So if you have a detailed syllabus and all, you can please go through that. So